To install IntelliJ Studio, first we have to open the web browser. Then we'll type in IntelliJ IDEA in the search field, and then we'll click on the first link. Next, we'll select the download link, and then the Community Edition. Hit download, and wait for the file to download fully. Then once it's downloaded fully, we can click on the file and open it. That will start the setup process for the studio. Next, we select the destination folder. Then we will select 64-bit launcher and to download the Java runtime environment. Then we'll hit install and we'll wait till it's done installing. Then once it's done, let's launch it and set up the rest of the environment. So let's not import any configuration settings. Accept the license agreement. And then the dark theme, because that's a little easier on your eyes, but it's a personal preference and you can always select the lighter theme. Let's create a new project to test. First, let's select Kotlin. Then we'll see if you don't have a JDK installed, let's download it. This is the link we'll use to download. And then accept the license. And then the Windows version of it. Once it's done installing, just hit open and follow the installation instructions. Take a note of the installation location because we will have to use it later. And now it's done installing, the first step. The next step, let's load the JDK that we just installed. We'll go to the directory where it was installed right now. By default, it's in Program Files Java, and we'll look for the latest JDK, which was 10. Now it showed up at the top. We can hit next. We can give our project a name. The name doesn't matter because this will be a sample project for testing if the studio has installed correctly. So next, in the left side, we will select the project tab. We will create a new Kotlin file. We'll call this file, and we will create a simple main function with by default it takes arguments type of a list of strings, array of strings, and then we will just print a command line text saying hello world, and then we will run the application. To run it, we'll select the play button to the left of the main function, like so. Hit run app KT, and then at the bottom of the screen, once it's done building and compiling, we will see the output on the command line. And the command line says hello world. And like so, we finish the installation of the studio. To install IntelliJ Studio on a Mac, first open and then type in IntelliJ IDEA in the search field. And then the first link will take you to the JetBrains website, where you want to select the IntelliJ IDEA download link. On the next page, let's select the community version. It is free. Once it downloads, you want to open the file. Here already have a file downloaded, so we don't have to wait. Let's open the file. Next, drag IntelliJ into the applications. Now let's wait while it copies. Once it's done, let's open the applications folder. And there we will find the icon for the studio. Let's allow this and give it a second to load. Now that it loaded, let's try making a new project just to test that everything works. Here, make sure you select the Java on the left and then the Kotlin type down here. And then let's go ahead and download the JDK in case you're missing the JDK. Here's the link we want to download. And here we want to accept the license and agreement and find the Mac OS from the list of the links. Once it has downloaded, let's find it in our downloads and open that file. Let's double click that icon and we will just follow these steps forward. We'll enter that in order to sometimes remembering the password can be challenging. And now, while it installs, we can grab a nice cup of coffee because this might take a couple minutes. Let's try and find that SDK that we can just install again. So now it will be under the our HD, then library folder, then Java folder, and then Java virtual machines, and then finally the version of the JDK we installed. Here at the top we will see that the JDK showed up in the text box. We hit next, and let's give our project a name. We'll call it sample project, because this is just for testing if everything will work. Everything seems to be successful. So on the left side, let's select project on the left side, open the project pane. Here under the sample project we'll find the source directory and create a new file. In order to create a new file, let's right click the source directory, then select a new Kotlin file, and let's give our file a name. We'll call it app. So now let's create a sample function. You just have to copy this. So it's going to be a main function that's ran once we're going to test it, and it takes an arguments list that's type of string, and the body of the function will just print a command line output saying hello world. In order to run this function, look to the top left beside the function declaration. It's going to be a play button. Press it and select run app KT. Now at the bottom of the page we will see that it is compiling and building the application. once it's done building and compiling, we will see a console window, and there we will see the hello world message that we made our code print. The building and compiling sometimes, especially for big projects, can take up to a couple minutes. Luckily, this is a small project and it shouldn't take more than a few seconds. And that is how you run a sample project, and that's our message in the console. And that's it for configuring the studio. Now we can start writing some serious code. Hi, Alexei here again. So I'd like to welcome you to this course, and I'm glad you decided to join and learn fundamentals of programming with Kotlin. For the first lesson, we will learn the very basics. So we will start with variables and data types, as well as how to print to console and how to get users' input from a console. Let's start. Variables and basic types are the fundamental building block of all software. So it's very important that you follow along and focus on all the information that I'll be presenting to you today. So what is a variable? You can think of it as an object's property. So here we have a little image of a person. So this person has different properties, like eye color, the book that the person's holding, pen type, or the favorite color of this person. So these things would be variables, making up the definition of this person. So variables store information, for example, like eye color. And this information can be any type, because eye color is one type of information, book is a different type, pen type is different, could be jeans, could be dress pants, the book could be a magazine, could be a journal, could be a novel, eye color could be blue or green. And these properties can change or might be immutable, meaning you cannot change them. For example, eye color will stay the same. The book type can change. This person can be holding a journal, but then they can put it down and pick up a magazine or a novel. Then can be unknown. For example, what is this person's favorite color? They might decide to keep it a secret or share with us. So, or for example, if they're not wearing a hat, right? We don't know what kind of hat this person has right now. It's unknown. Or it's not available. And this data can be shared with people or kept a secret, like the favorite color. You can decide to share this or decide to keep it private. Variables and their mutability. So mutability means if you can change it or not, versus the direct opposite, something that's read-only, that you cannot change. So the basic syntax for a property is, especially for a mutable property, you have a variable in the beginning, shortened to keyword var, property name, and then you have optional property type and optional property initializer, and then getters and setters. We'll get into these in more detail later. So for example, here we have a variable for a person's height. In this case, it's 175 units. It's a number. And this definition is exactly the same as this definition. Only here we explicitly state the type of a number. We'll get into types, data types, in a few minutes. So this definition is exactly the same as this one, whereas here we also decide to specify the getters and setters. These are accessors to this property. And we'll get into detail for these in the further lessons. So let's get to read-only property. Why would you want to have read-only property in your software? Well, that's very common actually. Sometimes you want to specify some value that never changes throughout your app. For example, like a speed of a moving game object, you might always want it to be the same. Or the name of a character in the video game, that's always the same. There's very many situations where you want to have a read-only property. And you should always think ahead if you have a changeable property or not. If you never plan to change it, you should always make it read-only. And to make it read-only, you have to start with the keyword val, standing for value, and then property name, optional type, then optional initializer, actually required initializer. We'll need to initialize a value because it has to be defined to something. And then only a getter, no setter defined. We'll get into getters and setters later. So here's an example, a simple example for eye color. Here it starts with the keyword val, the name of the variable, and then the assignment of the actual value. So this is exactly the same as this line, but here we define the type explicitly. Whereas in the first case, the compiler guesses the type implicitly, knowing that, hey, this is a string, this is a text, and I will know what type it is because I can see it right here. So compilers in Kotlin are pretty smart. And again, this is exactly the same as this, but here we define a custom getter. Sometimes you want to have some kind of logic running on get and on set functions, but we will get into that in hands-on section. Primitive types. So we already saw an integer and a string, but let's go into more details and let's get into other types as well. So we have booleans, which can only be true or false, characters, which is a single character, and then strings that are made up of lists of characters. And now I have various types of numbers. We have a byte type, we have a short, int, standing for integer, long, float, double. And all of these, they serve a purpose. Some of them store smaller numbers and some of them store bigger numbers. Some have a decimal point precision and some have a lot of decimal point precision. Let's begin with the booleans. So these can only be true or false and is used to store binary states and used in decision making. So one example would be whether you want to display some kind of a greeting in your app. So the very first time the app launches, you'll check a boolean, should display a pop-up. And then we'll set it to false after we show it, but initially it'll be true. And if it's true, we'll display a pop-up. Here's another example of the syntax. So we'll start this one with the variable, var keyword, give it a name. In this example, we'll say someone likes coffee equals false. That's quite shocking, I know. But then we can change this value saying, hey, we do like coffee equals true. And that's how you reassign this value. Then this definition is the same as this definition. But here we do it in two steps. First, we define the variable and state the type of it. Hey, it's a boolean. Next line here, we will assign a value to it. Likes coffee equals false. And we can actually do this in one step, saying, hey, variable like coffee, type of boolean equals false. And in this case, we make sure the compiler knows exactly what type we want this variable to be. Characters. So they're used to store any single character, right? Like a single letter. Again, you can use them for some kind of logic in your code. But often they're used to compose text. And it's rare that the developer would use the characters on their own, unless you have some very specific cases and you want to be creative and use these. And the syntax is like this: variable name, type character, and then we assign a letter to it. And make sure when you assign a letter to it, it's always in single quotes, because double quotes will mean a string. And then reassigning is the same. Name, that's already been declared, equals, and then a different value in single quotes. Strings. So strings are used to store text, obviously, and it's a combination of one or more characters. Usually it's useful to think of them as a list of characters, because under the hood, in the implementation of the string class, it's actually a list of characters. And the syntax for it goes like this: variable name, type, and then assignment. Name equals, and then some value. And make sure these are in double quotes, because single quotes are a single character. And to reassign is exactly the same as before. Variable name equals, and then a new value. So the string templates. This is where it gets a little bit more interesting. So in Kotlin, how would we join multiple strings together? Well, this is where we use string templates. So the string is within the double quotes, and the template is this part. It has a specific syntax: $, and then the variable name. And this variable's value, which in this case is Alexei, will always be added into this template. But it can be even more complicated. For example, we can put an expression inside the string template. So to have an expression inside the string template, we need to do $, and then put the expression inside the curly braces. And that will print out 2 plus 2 is, and then the Kotlin runtime will do this operation and then tell us 4. Numbers. So there's different types of numbers, and don't worry if you don't remember all these maximum and minimum values by heart, as you can always look these up. So with numbers, you kind of have to know before you begin, or before you create your variable, what is the maximum and the minimum value that's going to be stored in these variables. Because you want to be as efficient as possible with the space, with the memory that you use, because bigger numbers and numbers with bigger precision will use up more space than the smaller ones, smaller numbers. So the minimum and maximum, they actually are related to the actual bit size of these values. So bytes will be 128 to 127, then short, so this will be 2 to the power of 8 minus 1, and this will be negative 2 to the power of 8. And short is slightly bigger, the value, integer is really big, and long is huge. So most of the time, if you're using real numbers, you want to use integers. Sometimes if you're working with really small numbers, you can pick byte short or int, but most of the time it will be integers. Then floats. So the difference between integers, long, and float is that floats have decimals. As you can see, 3.4028 times 10 to the power of 38 will be a really huge number. And this one actually has 6 decimal places. So it can be like 0.0006 or 1, right? You can have 6 decimal places at the end after the period. And then double has even more precision, has 12 decimal places. We will play around with all these numbers more in the hands-on part of this lesson. So again, let's reiterate what numbers are good for in Kotlin. So they're used to keeping quantity. Integers and floats are most commonly used by developers to kind of simplify our lives. We keep it consistent, unless we need something extra and something more precise. But if you're worried about code performance, obviously you want to pick the right type of a number to hold the appropriate size. And then there's slight syntax things to remember for long numbers and floating point numbers. So here's an example of some code. We have a value, name, type, and then the number we store. So we won't be able to store anything bigger than this because unfortunately this number only allows up to 127. Then we have a maximum number for short here, for an integer, for a long, as you can see, long fits a really big number. And then to differentiate between a long and an int, long has a letter L at the end when you define your variables like this. The next one is float, variable name, type, and then your number. So here we'll do 0.123456f. For floats, you have to add this at the end of your declaration. And then for doubles, as you can see, it has more precision. But it doesn't have to start with a 0. This can be 105.123456, and so on. It doesn't have to be a 0 at the beginning. Alright, so you saw this in some of the earlier examples. So let's explain what this double slash is. So it's a comment. You can add comments in your code and they're not going to be compiled because they're meant to document code and usually to hold some kind of information for developers, like describing fields, functions, what some of the code is meant for, what it's designed to do, how it works. So any kind of documentation. Also, it's useful for adding to-dos in your code. You can do a single line comment or multi-line comment in case you have a lot to write about. Okay, so how would we see what our code does? Well, here we're going to use console output and console input. The console output we can print to the text console. So it's used for displaying information. And it's used in terminals like CMD, command prompt on Windows, or a whatever it is on a Mac. I believe it's a terminal. And then it's used for debugging. You can sometimes print out some text to the console to see what your software is doing. It's also useful for communicating with users. And then we have two functions. One that is called print. Another one is called printline. And they can take string, integer, string, any number, characters, or any primitive type that we just covered. So the difference is print prints everything in a single line. So here we have 3 lines of code, but all of them get printed in 1 line. Here we have 1 line and 2 lines of code, and this will print 2 lines here. So this first one will get printed as 1 line, and then the second will get printed as another line. So println is pretty much a convenience function that starts a new line after the text that renders. Now, how do we get input from the user? Well, we have to prompt them, and we can do it in the console. So we have a function called the readLine, and we use it in order to get users' input. So to get users' input, we also have to store that value in a variable. And here, the user has to hit enter for it to finish. Then, so in this example, we have 1 line that asks, hey, please enter text. Then this line of code will wait until the user types something and hits enter. When they hit enter, this line will return, this function will return a value that will be stored in this variable. And then we can do whatever we want with this value. What we do here is we actually gonna print it back to the user. Like so, you entered semicolon and then this variable, because it's a template and the variable will be put here. And this concludes the theory part of this lesson. But knowing theory is not enough. Let's apply what we learned and let's write some code. To start writing code, first we need to launch the IntelliJ IDE, give it a few minutes to load. This might take some time. Then, once it's done loading, let's create a new project. Then here, let's select Java at the top left, and then Kotlin in this section. If everything's configured correctly, you should see Project SDK here, and you should be able to click Next. But if something's not configured correctly, please refer to the previous videos where I showed how to set up the IntelliJ IDEA Studio. So let's press Next. Here, let's give our project a name and select the folder where we wanna save it to. I'll call it hands-on project. Doesn't matter the name as long as you remember where it will be located. Let's hit finish and give it a few seconds to load. And here, once it's done loading, you'll see an empty project. You can full screen it. And in the left side panel, you can toggle it by pressing the project button here. Under your project name, you'll see 2 folders. You'll see a hidden one that starts with a .idea. That one we don't modify. We will be always working with the source folder. In the source folder, let's create a new package. Packages are folders, and they're just logical units you can use to have little packages of code that you can then use or just separate the code. I will be creating a new package per lesson. Let's call this one variables. And if you're curious to see the structure, you can actually right-click press Show in Explorer, and then here you'll see your project folder with the source folder, and then here you can go into it and you'll see your variables folder. And then once we create a new Kotlin file, I'll call it variables example. You'll see your new file created automatically with the package at the very top. Now we can go back to the folder variables and we'll see the variables example.kt file here. So to get started on any kind of Kotlin application, first we need an entry point, a main entry point, and actually the main entry point must be called main. Take some arguments and then have some kind of implementation. If you don't know the function syntax, it's perfectly fine. We will cover that in a later lesson. For now, we will worry about learning how to create variables. To run it, you can run it from here by pressing the green play button and selecting run, and then your variables.variables example file. Or you can use this shortcut. On Windows it's Ctrl-Shift-F10. On the Mac it will be a different shortcut. Or you can go to run, and you can select run, and then select this file, variables.variables example kt, which is this file. Let's give it a few moments to build for the first time. This process can take a very long time for big projects. And then once it's built, at the bottom in the Run tab, you can toggle it like this, you'll see the output. And there's no output really, other than the successful finish. So, to print something, do you guys remember the function name? It's println for print line. Here we can type in any text or you can pass any primitive variable and it will print it to the command line. Let's try this again and see what kind of output we're gonna have. So it prints hello world. Great. Now let's create a integer, or actually let's create a byte type of number to hold age. So because we will not be changing it, let's make it into a value. So a value keyword, val, is a mutable variable, something we define once and then cannot be changed. There we go, 27, and then let's print it. Run it. There we go, the console prints 27. But let's format this a little bit better. So let's add a string template around this. So the way we're going to do it is we'll open double quotes, we'll type in your age is, and then placeholder for our variable and close the name. So this is variable age defined here, 27. It will be inserted into this placeholder and then get printed to the console. So let's run this. Perfect. There you go. Your age is 27. Now, let's create a new variable called name, and let's type in our name. This will be a string. Now, let's print it out. Now, do you guys remember how to do string templates? Let's add some text before our name variable. $sign and then the variable name. Now let's print it out and let's see what happens. Now the console has two outputs, two lines of output, your age and your name. Okay, this is great, but how do we prompt the user to enter this from the console without us having to declare these beforehand? So how do we make these dynamic? That's a good question. So do you guys remember how to read line? But actually before that, let's format this a little bit. Let's do print a message and then we will do read line, and whatever read line will return will be stored in the age variable and then printed in the next line. So let's do the same for name. Okay, and let's run this. Please enter your age, 27. Oh, and I forgot to add a label to this, to the name part. So, to enter a label before we ask for the name, let's do this. Print please enter your name. Okay, let's run this again. There we go. Please enter your name, 27. Please enter your age. Prints out your age is 27. Then please enter your name, Ollie. Your name is Ollie. Great. I know that. Now, how would we do some math? For example, can we do a little bit of math and see what's my age going to be in 3 years? So, let's try this. Value. And we can actually make this even more complicated. Let's prompt the user to enter how many years to add. Number to add to your age. Now, value, age, let's just call it number. And let's make it type of a short. And then equal, read the line. Now, we're gonna have an issue here because readLine always returns a string and we're trying to store it into a short. So how would we do it? ReadLine has a function, so a string has a function called toShort. But the problem here that readLine can return empty. So let's fix that by asserting that readLine is never empty. We will go into operators in a later lesson, so don't worry if you don't understand assertions yet. Now, let's fix up our age, because our age is also a string. So let's convert it to a short. We'll do it exactly the same way as we just did for number. Right? Then, now let's print this out. And we can do a string template. And we will make it a little more complicated. So, your age in how many years did the user enter? So, number. And then we'll say will be. And now we'll add a statement. So we can have a complex statement inside a string template. To do that, we have to do $sign and then two squiggly brackets. Now, let's do age plus number. And this will be more interesting example. Let's run this. Wait for it to build. 27. Your name. Okay. And what's the number we want to add to my age? Okay, let's see. 3. So, the app prints your age in 3 will be 30. That doesn't make sense, so let's do 3 years. Now it makes a lot more sense. And this is it for the first example. Well, let's run this again. It'll be 30 years. Let's format this nicely. Run this one last time. And finally, 10. Oh, I'm 7 years old now. Whoops. But hey, this is the fun part of coding. Now you can play around with variables and string templates and console output and input. And make sure you do the assignments for this lesson, because they will be very important. And feel free to explore and try different combinations of things, because especially when you get started, coding is all about exploring and trying out different combinations of the things that you learned. I hope you enjoyed the first lesson. See you in the next one. Bye. Hi, Alexei here again, and in today's lesson we will be talking about programming operators. And operators are the basic building blocks of statements and expression in any programming language, so pay close attention. Understanding operators is extremely important for any kind of programming language, so make sure you pay close attention to the slides and then the hands-on section. And also, please do the assignments after this lesson. So, operators. A lot of people think programming is math intense, and that is true for some forms of coding, but not all. A lot of desktop and mobile applications rarely require strong mathematical knowledge. There are, of course, some situations when you do have to do some digging around to figure out the formula, but usually it's not about the math. So there's nothing to be worried about. This is not too complicated. And operators, they are special symbols. You can think of them as operators in a mathematical equation where they operate on parameters or operands in that expression. They're also used in assignment operations. Some are there for convenience to make certain expressions or statements shorter. There's a lot of Boolean algebra operators we'll cover, and also they're heavily used in control statements like if statement, when statement, and other statements that we'll cover in later lessons. So these are the basic ones. The first four are pretty much the same as math, but this one is the modulus operator. It is used to find the remainder of a division. So for example, you have 10 modulus 3. The result of that operator or of that statement will be 1. And let's say 3 modulus 2, the remainder is 1. And 11 modulus 3, remainder will be 2. So, assignment operators. These are pretty much shorthand operators for things like addition, subtraction, multiplication. For example, A plus equals B is the same as A equals A plus B. So instead of writing this whole thing, often developers will write this kind of a shorthand expression. So when reading this, it's probably easy to read it as A equals itself plus B. A equals itself plus B, and so forth. So these are also mathematical, and part of them are for convenience. So the first one explicitly states that this expression will be positive. This one inverts the sign, so making it negative, or if it's already negative, into a positive, just like in the math class. Then this one, not. This not operator, if there is a Boolean expression here, which it often precedes, it negates. So it will be read as not true. If A is true, this expression is read as not true, meaning false. Plus A, increment by 1. Minus A, decrement value by 1, whatever the A value is. Next is comparison and equality. These are often used in control statements. For example, comparing two values. If expression A is greater than B, and this leads to true, then the statement is used to execute some kind of block of code. And then if A is smaller than B, it's false. And here, if A is smaller than B, that will result in true. If A is actually bigger than B, the value, the expression will resolve to false. Greater or equal. So these ones are not inclusive. For example, if A is equal to B, what will happen in this situation? Does it meet the requirement? A is less than B. No, A is not less than B because they're equal. Here, A is greater or equal to B. So if A and B are the same number, like 5 for example, this expression will be true. Same for this. So A equal B is an equal, you compare the values. And remember, single equal is an assignment, double equal is a comparison of value. And then last one is not equal. So it's just the opposite. If A is not equal to B, then do something, comparing the values. So if A is 3 and B is 4, that expression will equate to true because they're not equal. Logical operators. So these operators are commonly used in Boolean algebra and often used in control statements. For example, well, this one is an OR, logical OR, and this is a logical AND. What is a logical OR? So it compares the values on its left and on its right, and either of them has to be true for this whole thing, for this whole expression to evaluate to true. This is true or this is true, then this expression is true. Now, what's the difference between OR and an AND? AND looks at the both statements, statements on both sides, and checks. Okay, this has to be true, and this also has to be true. So both of these have to be true for this expression to equate to true. Whereas here, again, the logical OR, only single one has to be true. Okay, that's it for the slides. Now, enough talking, let's apply our knowledge to the actual code. Let's begin. To begin, first let's launch IntelliJ Studio, and then let's select the source folder, right-click, new package. Let's call this package operators. Okay, and then let's create a new Kotlin file, call it operators example. And now let's create a main function, like so. And now let's begin with arithmetic operators. Actually, first, let's get the user to input two numbers that we will be working with and testing all the operators with. So let's create two values, A and B. A will be type int, and B is also type int, just for simplicity, so that they're the same type. Now let's get the user to input something. Do you guys remember how to write to console? Right, print line. Please enter a value. And then let's make A equal to this value. And how do we read the user's input? Read line. So to make sure it's not null, we will add 2 exclamation points. For null safety, we'll cover null safety in a later lesson. But let's change a few things. This is not the value. We'll have to change this. We'll have to change the value of A. So the keyword is not val, it's going to be var. So it's a variable. Same with B. It's variable. We're going to be modifying these values. Now, what is the issue? Type int and type string. Right, so let's convert this to int. Right, there we go. And now, let's prompt for the second value. Second value. And now let's read it. B equals read line, same as before. Can't be null and has to be an int. There we go. Now let's play around with some arithmetic operators. So what will be the sum? Which operator would we use to come output the sum of those two values. It will be a plus. Pretty simple. Now, what about product? Which operator would be used for a product? It is this operator, the asterisk. Alright, now, modulus operator. A lot of people have problems understanding this, but it's not complicated. The modulus operator, or modulo operator, just returns us a remainder of whatever this A divided by B, whatever the remainder is the modulo. And it's a very useful operator in some cases. So now let's print these out to the console. So this is how we'll print to the console. Now let's run this. Okay, let's enter value. Let's enter 10, and then second value we'll do 4. Now the sum of 10 and 4 is 14. Yeah, 10 plus 4. The product, which is 10 times 4, is 4. And modulo of 10 and 4 is 2. Great, because 4 fits into 10 twice, and then the remainder is 2. So 2 is the actual remainder. And now let's do the assignment operators. Do you guys know do you guys remember what the assignment operators are? So first, let's do the plus equal one, which will be like this: A plus equal B. And the value of A now will be what? Will be the value. It's actually the same as A plus B. So this would change the value of A to 14. But yeah, let's print this out. Alright, and now let's run it. Let's see. So let's do the same values again: 10 and 4. So A is not 14. Yep. So A plus itself plus B. So A is now equal to itself plus B. A was 10, became 10 plus 4, and storing the result in A. Right, now let's change the value of A a bit. Let's do self divided by, let's do self divided by 2. And let's print it. What do you guys think the value of A is gonna be now. If we enter the same values. A is now 7, so half the 14, and stored in A, the variable A. So itself divided by 2. Right, and now let's do the increment and the decrement. So let's do plus plus. Do you guys remember the increment and decrement operators? Plus plus A. Now let's see what the value of A is. What do you guys think it's going to be if we enter the same values? 10, 4. A is now 8 because we're making A equal to itself plus 1. Now let's do a decrement operation. You guys remember the operator for it? Yes, double negative sign. Right, now let's print it. And 4. And A is back to 7 because 8 minus 1 is 7. Okay, that was the decrement. Let's do the unary operator. So let's do the negation or unary. But we'll have to use it with a boolean. For example, let's create a value. Let's call it likes candy. And let's make it equal true. And let's print it. They're like candy. And the answer will be, let's see, this will be true. We'll run it in a second, but now let's do a negative. So let's do let's actually change this value. Right, so this is how we'll change it. We'll do not operator and then the actual variable that holds true. So it's gonna negate it. It's gonna do the opposite. And now let's run these two. So, do I like candy? Yes. Then we change it, we negate it. And now it is false. I don't like candy, and the value is false. Great, so that's that. And next, let's do comparison. We will compare A and B now. So let's print out some text and start comparing them. first one will compare if A is greater than B, and inside the string template we'll have an expression comparing A to B. Next one will compare if A is less than. Next one is greater or equal. And then next one, let's just do equals. And now let's run these two. So for the first run, let's just do 10 and 4 again. Okay. Let's see. A is greater than B. 10 is greater than 4. True. Is 10 less than 4? False. Is 10 greater or equal? True. Is 10 equal to 4? False. Alright, now let's do similar values to see what happens. Let's run it. Let's run it again. So let's do 5 and 5. Now we can see, is 5 greater than 5? No, they're equal. Is 5 less than 5? No, they're equal. Is 5 greater or equal than 5? Correct. True. Is 5 equal to 5? True. And those are the comparison operators. They're pretty useful in control statements like if statements, if else, when, and all the loops we'll cover in a later lesson. And finally, let's do some logical operators. Let's create two Boolean values so we can flip them easy. We'll call them C and D, and we'll make one equal to true and another one equal to false. Now, let's compare them. So first, let's compare C or B. It has to be true for the expression to evaluate. True. Let's print it out in the template. So let's do C or B. Let's see what this prints. Oops, sorry, C or D. And let's also do an AND, so it's easy to compare. C and D. Okay, let's run it. The first numbers don't matter. Now let's do, let's see, C or B. True, C and B, false. So C or B executed to true, evaluated to true because one of them was true. For the AND, they evaluated to false because one of them was false. This would only evaluate to true if all are true. So let's make this a little more complicated. Let's do a comparison as well. C or D or A is greater than B. and then here C and D. Oh, actually, let's make it and A is less than B. So let's see, what kind of numbers do we need to make this expression to evaluate to true? So C will be true and D will be false. So no matter what this expression is, all of this will evaluate always to true because one value is true. But for this one, what do we have to have? What do we need to have for this expression to evaluate to true? So I just changed D to true. Now C and D and A is less than B. So this one has to be true, C has to be true, D has to be true, and then A has to be less than D. So let's enter a value. So let's enter 5, and now it will be less than 10, which will be value B. And then C and D, actually, let me run this again. So now let's run it, and let's enter the first value. It has to be less than the second value. So let's do 5, next one let's do 10. Now, as you can see, the last expression related to true. Actually, let's fix up the text here, and A is less than B. And then let's fix this one up. Right, let's run this again. Now, let's enter 10 and 10. So before I execute it, which of these statements will be true and which one of these will be false? Will this one be true? Will this one be true? Or will one of them be false? So first one is true, because at least one of these values, well, actually both C and D, are true. And the second one is false, because this statement is false. But we can actually make it a true like this. Right, now it's true. So feel free to play around with the values and feel free to write your own expressions to test out all these different operators, because understanding them and being comfortable with using them is extremely important for a lot of writing complex code and writing complex systems. So make sure you're comfortable and knowledgeable of all the different operators. And I'd like to thank you for staying with me for another lesson, and I'll see you in the next one. Thank you. Hi, Alexei here again, and in today's lesson we will be talking about functions. Functions is what allows our software to be reactive, fast, and alive. So let's get started. Functions are extremely important in making your code reusable and dynamic. Any skilled developer has to have a solid understanding of this concept, so make sure you pay close attention. The functions, they take one or more inputs and do some kind of operation on those inputs and produce a result. So Usually the statements inside the function body perform a specific task, and they're related. Functions help to break out complex tasks into modular pieces. Because the inputs can be different, but our operations on those inputs stay the same, therefore we can reuse the same function in many different places to avoid copying those operations over and over again. And these, you can think of functions as actions of a complex entity. For example, here we have entity dog. Dog's functions can be run, bark, sniff, roll, sit, fetch. And they're logically grouped, right? All of these apply to this entity. And they can be combined to perform complex tasks. For example, a dog can play. Playing involves running, barking, rolling, fetching. So all of these combine under this play function to create a more complicated behavior. So, function syntax. At the first glance, it might seem very complicated, but in reality, it's actually not. So let's see what it's like. Every function starts with the fun keyword, standing for function, shortened to fun. Then we have function name. In this case, in this example, it's called add, and then one or more, or zero or more parameters actually. So there can be none, or it can be one, or it can be many parameters here. Now, each parameter has name and then a type. Name and a type. Next, the return value goes after a semicolon. This is the return value of this function. The return type of this function goes after the semicolon. And then the very last line of the function, we return the type, that value of this type, with the return keyword. And then the body of the function can have many complex expressions. In this case, we're just doing addition, storing that, creating a variable and saving the value of this addition in the variable, and then we're returning this variable. So functions can return nothing. Then when it's returning nothing, you can omit the unit type. So by default, when you're returning nothing, you're actually returning unit type. But the Kotlin runtime or Kotlin compiler and all the IDEs, they are smart enough to understand that if you're not returning anything, you don't have a type at the end of the function signature, it will be unit. So just pretty much nothing. That's the syntactic details of returning nothing. But this is pretty much how you normally will return nothing from a function. Calling the functions. So there's two types of functions to remember. First one is Kotlin standard library functions. We've used them before. Remember the print line function and the readline function? They are the standard library functions. And they can be called from anywhere. You don't need to do anything extra or anything special. Then the user-defined functions. That's the second type of functions. They have to, when you call them, you need to know the path to them. Because remember, those functions can be declared in a different package. And we have to know and specify what the package is in order to call a function. So in this example, we have a function called hello from far, and that's created in a package called far. And if you don't want to write the full path because it can be fairly long. It can be package, and then inside that package another package, and there the function. You can actually import that path and call the function directly, only if you have an import at the top of your file. We will go into this detail in the hands-on section of this course. And yes, all the paths to the function have to be fully qualified, meaning that there have to be correct path to it, like package.function name. Alright, that was fairly short lesson, but now let's play around with functions and see what kind of cool code we can write. Same as last time, we will begin by opening IntelliJ IDEA Studio. Then we will create a new package. Let's call it functions. And then let's create a new file. We'll call it functions example. Now, in this file, let's create a main function. See, now that we know the syntax, this function is not a string, where we have the fun keyword, name of the function, then the arguments that it takes or the parameters that it takes, and this specific function has no output, no returning value. So now let's say we had some kind of a print message in this function. What would we do if we wanted to move it to a separate function? Actually, let's give this a different message. Let's say and let's create the function that will print this for us when we call it. So do you guys remember the syntax? We'll call this function print lesson name. We'll take no parameters. We'll return nothing. And in the body, we will just have this. But declaring it and implementing the body is not enough. We have to call it from a runnable code. So in our main, we will call print lesson name. Now, let's see what happens. Great. Now we have our message printed in the console. Now when we can call this multiple times, like so, and it's gonna print it again. And as you can see, we don't have to copy this message, we don't have to copy this implementation, we can just keep calling it over and over again. So if we wanted to print a string but have some kind of modification of that string, changing it a little bit, how would we do this? Let's create a new function and we'll call it print lesson section name. And now if we wanted to take a string parameter, how would we declare that? First, we'd have to give that parameter a name. And next, we'd have to give it a type, string. Great. And now we can just have the print line call here, and then let's format it a little bit. Let's just do something like call our, or insert our variable here, and then format it like this. And this should give us a nicely formatted section heading. So instead of this one, let's do and let's give it a name saying functions returning nothing. And let's run it. Okay, and this printed called the first function, then the second function. First function printed this string, the next one formatted this value and printed this. Now, what if we wanted to separate this logic a little bit more? Let's create a function that just formats the string let's call it format section, and let's give it a string. Let's give it a variable. Call it name, type of string. Now let's do the format. And actually, because this will be formatting it, we want to return the formatted string, which is going to be type of string, obviously. So now we will take that and return it from this function. And now here in the print lesson section name, we will call format section and just pass through the name variable. Name variable, then this function gets called, receives this parameter, and then returns formatted section name. Now let's run it. As you can see, the output is the same as before, but what we can do now is we can actually nest function calls, right? So we can do something like format section that takes another format section parameter. And this will first call the inner function, then this will do some kind of processing on the name, return the value, and then the outer function is going to receive it, will do its processing, and then the other function will receive it, which will be the print line in this case. So you can also visualize it like this, if this helps. First this one gets called, then this one gets called, then this one gets called, and this one returns a value, this one returns a value, and this one will just print it. So let's see what it looks like. Great, so we got it formatted twice. We have more styling around the heading. It's pretty cool. Alright, now let's create another section heading. And let's create a function that will add two numbers together. It's pretty simple, right? So let's create a value, and let's create a function first. This function will take two arguments, a type of int, and b type of int, and then we'll return a value type int, and then in the body we can just return a plus b. Pretty straightforward. Now, to assign to this value, we have to call this function with a and b. So let's do 10 and 5, or 10 and 2. Now let's run it and see what the output is. Or we're actually not printing it. Let's print it out first. Print let's call it some function result equals the sum. Some function result is 12. Perfect. Now, what if we want to do multiple, have multiple numbers added up using this function? So for example, if we wanted to add 2 numbers, add another 2 numbers, and add those 2 numbers together, we can nest the functions, right? This would be something like we can do 11 and 5 here, and then we can do 3 and 4 here. So the outer function has 2 parameters. Both parameters are actually returned values from these functions. So because the sum value returns, it will become a parameter to this function. So it would be the same as declaring a value like this, a equal, and then using the a here, and then b equals this function call, and then the parameter of this function. So let's see what happens. Some function result is 23. 11 plus 5, 3 plus 4, and then both summed up, yep, 23. Okay, so let's talk about the variable scopes and functions. So far we've been defining our functions, our variables inside functions. And like here, for example. And this variable is only accessible from within this function scope. If we wanna share a variable, or if we wanna modify a variable, a mutual variable, we'd have to have it declared outside this function scope. So we can actually declare a variable outside all of these functions. Let's call it count, and it's gonna be type of integer, and we'll start with 0 initial value, and then we're gonna modify it. Now let's now create a function that will increment this variable. And let's access it directly, this variable, without passing it as a parameter. So we can, and we can just call it by its name, and we'll do an increment operator on it. So now let's count the lines. Let's count the lines of our main function. So let's do increment count here, 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 and just do it here. And now let's print. And we can access this variable directly again, which is the count and the string template. And now let's run this and see what the output is. Output line count is 4. Perfect. So the value we started with 0. Now this function called increment incremented it by 1. Then every time we call this function, this variable was incremented. So that's another option for having global variables that you can modify from any function. Now let's create a function that will call multiple functions from within. So it'll provide some kind of a complex behavior for us. So let's create a new function. And what is the syntax again? Fun keyword, function name. Let's call it complex math. And let's take 2 arguments. So what is the syntax for it? For the function parameters? Name, type, again, name, type. And then we will return a string, right? Doesn't have to be the same type. The inputs and the output can be different types, of course. Now let's declare the actual implementation for it. So in this function, we will be combining the sum and increment. So let's do something like this. Let's declare an output value so that we can operate on it. Let's start with the initial value 0. Now first let's do a sum operation of A and B. Sorry, it has to be a variable. Var, as we have to be able to modify the output. So let's add A and B together, stored on the output. Now let's do output, and let's double it. We can just use the same sum function again. So let's do output and output, and also let's just call increment count. And now let's do output equals sum, and then let's use the count variable. And the output again. And let's also create a new function that does a multiplication. And we'll use it. Let's call it multiply. Again, 2 parameters, A and B. And this will return a product of A times B. And now, int value, integer product of A times B. And now let's finish our complex math function. So now for the output, let's multiply itself by let's do 4. And finally let's return this output value. And let's format it. Let's format this so we can say something like the result is, then the output value is part of the string template, and let's print. Let's create a heading first. And finally, let's call our function, but directly from the print line statement. Let's call complex math, and let's give it two values. Let's do 3 and 7. So let's run this. And now we see that the result is 100. Oh, nice. That was quite a coincidence. So we started with 3 and 7. A was 3 and B was 7. Then we summed up 10 to 10. Then we did 10 and 10 again, 20. This was 20. Then we incremented the count to, I believe it was 3 at this point. And then we summed up 3 and 20. And then we multiplied. Probably the count was a different value. Then we multiplied by 4. Yes, probably. The count was probably 5. And the result became 100. And then we returned the string composed of some text and the result value, which was 100. We returned it, and then here, print line accepted that value, and it printed it to the console. So the last thing we want to talk about is moving some of the functions to a different package and being able to call, or in general, calling functions from that exist in a different package. So let's create a package, and we will actually reuse functions from it in the following classes. Let's create a package called utils, and inside this utils package, let's create a file, Kotlin file, called util. And inside here, let's actually just copy paste one of our section name functions. Actually, let's copy paste both the section name and the format section functions. So let's cut them out of here, move to util, and paste them here. So going back here, as you can see, our code shows error, unresolved reference. Well, the reason why this reference is unresolved is because this function is not declared in this file anymore since we moved it. The compiler cannot find it. So to reference it there's two ways. First, you can do package name util dot utils dot and then the function name. That's the first one. Right? And everything will work if we run the code. Another option is adding an import at the top of your file, right below the packages. We will write import, then the package name, and then the function name. the one that we want to import is the print section name, right? So now we can remove this utils dot and then have the function name. It's just a little cleaner, a little bit less code. And that's how you will call a function in a different package. And that's it for today's lesson. Make sure you're comfortable and you know every in and out of function declaration and how to return values from a function. So make sure you play around with creating your own functions. It can be a lot of fun. And as well, make sure you do the assignments after this lesson. Thank you, and I'll see you in the next one. Hi, Alexei here again. And in today's lesson, we will be talking about arrays, lists, and ranges. So, whenever you have a list of data that you want to operate on, one of these data structures will be of great use. So let's learn how to use them. Whenever working with a list of data, some of the most important data structures that you can use are arrays, lists, and ranges in Kotlin. So let's talk about arrays or any type of collection. Usually they're indexed and you can access the items via the index. And almost all programming languages, the arrays are zero indexed. So the first item is at index 0, 1, 2, 3. So you start counting from 0. You can think of it as first item is in position 0, then 1, 2, 3, and so forth. So arrays are used to store items of the same type. You cannot have an array of items of different types because you have to be strict with the types of this collection. Arrays, once created, cannot be changed in size. And then you can also access items via the access operator, which are the square brackets. Arrays have a property of size, so we can always print out its size in case we need to know how many items are in the array. And once we learn for loops, we'll know how to iterate over every item in an array. So the syntax, you can create an array using the Kotlin standard library function, array of, and it's smart enough to know that these numbers are the same type. Then we can print out the size of this array by calling our array variable dot size. Now let's access the first item. In this case it's 1, so we can do array square bracket index 0, that's the first item in the list in the array, and that will print 1 to the console. Now this array access the square bracket 0 square bracket is the same as array dot get 0. Now to write an item to the first index or to any index, you do array's name access operator equals the value. So here we're modifying item at index 0 and we're storing number 7 in the first index instead of number 1. And then similar, we can use a setter calling it .set index and then value. So array.set 0, 7. Now if we print out the first item in this array at index 0, we'll see that it's 7. So lists in Kotlin are different than lists in Java. Biggest difference is that you cannot modify the items once they've been set, and you cannot modify size. So once an item is set, you cannot change it with the access operator. So for example, list item at index 0 equals 7, we're trying to assign it, it will not compile. This will not compile in Kotlin. It's not valid with lists. So they're used for a list of items that you never want to change. Size doesn't change, and the item values don't change. So again, same as arrays, the type of the items you store has to be the same. And that's lists compared to arrays. Now let's talk about mutable lists. Mutable lists are very flexible. Same, they must have the same type of item, but variable size. So we can change the size of the items in the mutable list. So in Kotlin, we have a mutable list of function in the standard library that will let us create a mutable list. And here we can modify it. We can add more items to it. Not just changing each item's value, we can actually add more. So if we wish to add an item at index 0, that's a value of 100, we'll do this, mutable list.add. And that will store one extra item in the very beginning of the list and print out, next line here prints out the size. As we can see, size has changed to 5 since the initial 4. Now, to insert at the end, we can call the add function, but omit the first parameter to the function and just call the value. And by default, it's going to add the value to the very end of the mutable list. Now, if we print the list size, it's going to be 6. Now, let's print out the first item, and it's 100. It's correct. Now, let's print out the last item. Here, we access it by mutable list.size minus 1. Because remember, size is all the items, it's the count of the items in our list. But remember, indexes start from 0, so we have to subtract 1 to grab the index of the very last item in this mutable list. Now, ranges. Ranges are a very interesting collection of values. They really simplify a life of, they make a life of a developer way easier when you have to create a list of numbers or a list of characters. So you can create the ranges, are a succession of values between upper and lower limits that you define, and then there's a certain operator that you use, the double dot, that will create a range. So to create a range in Kotlin, we'll do 0, or if we want to create a range from 0 to 5 inclusive, ranges are inclusive in Kotlin. So the range will contain both 0 and 5, and all the numbers in between. To create it, we'll have to write the initial number, 2 dots, and 5. And this creates a range. And here we'll iterate in this range with the for loop. We'll cover for loops in more detail in the next lesson. But here we'll pretty much just print out the value of each item in this range. And it will print from 0 to 5. Next, we can change the default order to ascending order. To it, we have a slightly different syntax. So it's initial value and then you have to type in down to and then the final value. This will create a range from 5 to 0 inclusive. And that prints 5, 4, 3, 2, 1, 0. And that's how ranges work. Now, let's put this to a use, because knowing how to create lists is incredibly powerful tool in every developer's toolbox. Now, continuing from the last example that we did, let's again create a new package. Let's call it collections. Let's call it lowercase. Now, inside this package, let's create a new Kotlin file. Let's call it collections example. Again, main function, and we'll start with creating an array filled with 5 zeros. So first we want to declare a value, right? A variable that won't change. Let's call it R, and then let's do array of, and let's do 5 zeros. There we go. Ooh, actually, first let's add a section header that we created within the utility function last class. So first import util, print section name. Now we can call okay. Now let's print this out. Right, to print out all the items, we're gonna use a for loop. We'll cover all the ins and outs of all different loops in Kotlin in the next class, but in this example, we'll use a simple for loop. So for loop has to have a variable that will assign to each of the item in the list. So we'll call it item in our collection, and now we can print the item. So basically what this for loop does, it goes for each item in this array. And item is just the name I gave the variable. Okay. Give it any name. And let's print this out. There we go, array of 5 zeros. Now, what if we want to... Actually, let's move this for loop into a function. So let's call it and the type will be array, and then type of int. So this is the actual type that this array of will return. It will return, since there's integers here, this will be type of int. This is array, this is a generic type, and the type is int. Now let's print all the items in this array. And now let's just call this function from here. Right? Let's run this. Again, perfect. Everything prints. Next, let's change all the items in this array to multiples of 2. How would we do that? So first, let's declare a value. So next, what we want to do is we'll iterate through all the indexes. To iterate through indexes of this array instead of the items, we can grab the indexes by doing this. Let's call the variable index in array dot indices. Now, what we can do is we can access each item by index. So we'll start with 0 until the index of 4, which will be the 5th item in this array. So now we'll assign a multiple of 2, but first let's do mult. And do you guys remember the multiplier operator that multiplies itself and then sets the value like that? And now let's set the variable as the value of that arrays at that index, and let's print this out. See if we have all the multiples of 2 printing correctly. But before, let's understand what happens in this for loop. Basically, we go for each index, starting from 0, going all the way till 4. So I will be first 0, then 1, then 2, then 3, and 4. And then mult variable will keep multiplying itself by 2 every loop. So first, there'll be 1 times 2. It's going to be 2, then next loop is going to be 2 times 2, and so forth. Then this line, we will be setting the array item at index I, will be setting to this variable. So let's print this out. So we have printed 2, 4, 8, 16, 32. Perfect. Those are the multiples of 2. And that's exactly what we wanted. Next, let's do lists. And pretty much the only difference between lists and arrays is that in lists you cannot modify the item once the list has been created. So let's create a list of 5 zeros. Now, if we try to modify the item at the first index, that's a read. But now to write that, see, we'll have a error saying unresolved reference, none of the following. Well, yes, the list does not have a setter, so we won't be able to set. This is useful for things like data that won't change ever since the list is created. So for this example, actually, let's do names. There we go. Those are the names. And now let's try and print it. So it's not, we cannot use our function that we just created. So we won't be able to use this print function to print this specific list because it's a different type and it's a different data structure. The previous one was a list, current one is an previous one was an array, current one is a list. They're different. So what we can do is we can actually create another function. We'll call it print list, and instead of integers, we're actually going to do type of any. So any will allow us to print any type here. Doesn't matter if it's an integer, string, or anything, because any is the base type of all the objects in Kotlin. We'll go into details of this in the later lessons. So let's see. Right, and then list. Now we should be able to print our list. Okay. Now the list. Okay, prints out the names. So next thing we will do is we'll actually create a list of lists. So we will have a list of first names and, list of name arrays. So a name array will have first names and last names. And then last name. So because lists or any collection can contain any type of objects in it, as long as it's the same type, we can have nested lists. Now, how would we print out this data structure, right? Because it's a list of lists. Would this function work? Let's see. So it does kind of work. It prints out our collections that are our lists that are printed out here. But what if we wanted to format them? What if we wanted to do something different? How can we iterate through all the nested items? So let's create a new function called print nested list, and then type of list. That's a type of list. Each item is in it as a list, and let's just do any for convenience. So now we have for each item. Actually, let's do names. Now we know that the items are strings, and we know the size is always going to be 2. So let's do first which index is the first name going to be at. Correct, it's going to be at index 0. And this is an expression, so we have to have curly braces here. Now let's do a second. Okay, and now let's just change this to print names list, and let's run it. First, second, perfect. So we have our output from the nested data structure here, where we have a list of lists. And next up, let's do mutable lists. Oops, sorry. Mutable lists. Again, let's create a variable that reference our list. Now, how do we create it? Alright, we'll use a Kotlin standard library function, mutable list of. Now, what should we store in this list? Actually, let's make it type of int, but let's not store anything, right? Because the difference with mutable lists and others is that we can always change the size. We don't have to have the list from the get-go. So let's fill this list with user input. Let's ask the user to enter 5 numbers. And now let's read the numbers and store them in these specific indices, or add them to the list. We'll add them using the add function, and then the readLine function, and we'll convert the string to int that the user enters. Now, we'll do this 5 times. So that the user enters it 5 times. And then, actually, let's print this out. So mutable list is a subclass of lists. We should be able to use our print list function to print our mutable list. Okay, now please enter 5 numbers. So let's do 5, 6, 7, 8, 9, and then it printed out all the 5 numbers I have just entered. That's the mutable lists. But now let's actually use a range to help us with this part. So to use a range, instead of repeating 5 times for the user to enter, let's do a for loop of a range of from 0 to 4, which will be 5 items, but actually let's do 1 to 5 because that's easier to understand, right? So for loop for e, doesn't matter what the value is, or doesn't matter what the variable name is here, but it's going to be 1 to 5 inclusive. This for loop, what it will do is will iterate through a range of 1 to 5, and each loop e will be from 1 to 5. So first loop's going to be 1, 2, 3, 4, 5. But what the value of e doesn't really matter to us. We just want 5 times to prompt the user this single message. We want to prompt them 5 times instead of copying this 5 times. So this is more efficient and cleaner looking code. So let's run this, and then we should be prompted 5 times. Please enter 5 numbers. So let's do it. 1, 3, 5, 7, 9. And we were prompted 5 times, like the range says, to enter 5 numbers. So that concludes our hands-on section of the course, of the lesson, and I hope to see you in the next one. Again. And in the next section of this course, we will be learning about control flow. So let's get started. And these statements are usually used to control the flow of execution in your code, or control the flow of the operations in your code. So they're extremely important, especially for creating dynamic and smart software. And these are pretty much the very fundamentals of any programming language. So before we get into the specifics, we have to look at the definitions of expressions and statements, because these definitions will be very important. So an expression consists of variables and operators, like so. 2 times 10. This is an expression. It will evaluate to a single value, which will be 20 in this case. And multiple expressions can be part of a statement. So the whole statement is this: product equals this expression. Now, what is a statement? Well, it is a complete unit of code, right? Like you can think of it as a line of code. Operates on variables or operates on statements and can consist of many statements. A statement may or may not change a value and may or may not assign a value. So product, declaration, and initialization is a statement altogether, whereas this is an expression. Plus plus product is a full statement. Print line, hello, or any full method call is a statement. Now that we know the difference between statements and expression, let's talk about blocks. What's a block? Well, block is a group of statements inside the curly braces. So here we can see a function, and we can see a function block starting here and ending here. Then inside this function we have 3 statements, so assigning the name, and then creating the string, and then printing out the string. So all of these 3 are statements. Then this is an example of an expression where we are creating the string template here, which once created returns a full string that completes the whole statement here. Now, the differences are important to know because in Kotlin, if-else expression is, unlike other languages, is an expression, whereas most other languages, it is a statement. Meaning that if-else in Kotlin can return a value, but it can also be used on its own without returning anything. So the way it works is if-else, in the if, in the brackets here, if this statement is true, if this expression is true, then if will print this line, execute this code block. Else, if this is false, this code block will get executed. So we can also use if-else as an expression. For example, like so. If this is true, return even. Else, meaning if this is false, return odd and store it in this variable. And that's the if-else expression. Now, when expression. It's like an if statement, but really useful in cases where you have many conditions to check. In an if-else, normally you'd be checking one or two conditions. But in a when expression, you can check many different conditions. So for example, we can prompt the user to type in one of the following three options, or they can type something other, and then store that in a variable, and then when we'll check. So when takes a variable, and then here inside the code block we have four different conditions. When color text is red, we will execute this code. When color text is green, we will execute this code. When blue, execute this. Else, anything else, then execute this line. As you can see, this is very useful for situations when you have many different conditions to check. Now, a while loop. So the structure of a while loop is like this. Check the expression. If false, just bypass the loop. Then, if the expression is true, execute the body. Once the body is executed, check the expression again until the expression is false. Now, here's an example. So loop count will be 10, and it's a variable that will be updated from within the loop. So first, when we're executing this, when we get to this condition check, loop count greater than 0. Is it? It's 10 initially, correct. Now we'll print it, then decrement it by 1. Now check again. 9, is it greater than 0? Yes. Print, decrement. And it's going to do this until we hit 0. Is 0 greater than 0? No, they're equal. So we will not enter this code block. We will just bypass it and continue the code execution further. Now, do while loop. It is similar to while loop, but it executes the body at least once and then checks the condition. So it is just a while loop kind of flipped a little bit. So the first we execute, then check the condition. First, then if the condition is true, execute again. Then condition is still true, execute. Condition is false, continue the code execution further through the app. So here's an example. We'll pick a random number between 1 and 5, and then we'll prompt the user to guess this number. And while the user's guess is not equal to the random number, we will keep prompting the user to guess until they guess it correctly, at which point we will print whatever the random number was to the console. Now, for loop, we already looked at in the previous lesson, but let's go over it again in more detail. So for loop is generally used to iterate through each item in some kind of a collection. List, array, mutable list, or anything else. Has an iterator. So in this example, we will iterate through each character in this range, because ranges also provide an iterator. So here we will go for every character in a range from A, B, C, and until F, and print them. Next one. So list of strings, basically we will print out whatever is in this list. Just the basic for loop. For each item we can give it a variable name in this list, print this variable. So with while loops and for loops and do whiles, you can break out of them when a certain condition is met. So the structure is like this. Inside of a while loop or a do loop or a for loop, there's usually an if statement with some kind of a condition. When that condition is met, we'll break out of this loop and will not continue to execute. So here's an example. While true, so this will be always true. We'll print out an index variable that starts at 0. Then if index is greater than 5, break. Well, is 0 greater than 5? No, we'll continue. Then here we'll increment and run the code again, because it's always true, this while statement. Now, check. If finally, once we do reach 6, we will break out of this loop. So as you can see here, we'll get up to 6. Then, if condition is true, we will break out. Now, what if we want to skip to the next iteration of this loop? We have a continue keyword. Again, inside the while or a do loop or a for loop, we will have a if statement, usually an if statement. And there we will check some kind of an expression. And that if that expression is true, then we will just skip to the next iteration, and anything following that if statement will not execute. So here's an example of printing all the even numbers. We will print every number in this. So we will iterate through every number in the range from 1 to 10, and then only if an item is even, meaning if it's not divisible by 2 with the remainder. So if there is a remainder, it means it's an odd number. We will skip the printing. If it's even, we will print that number. This is definitely a lot of information to take in, but putting it to a use in our hands-on section will definitely help you to get familiar with it and be really good at using all these control flow statements. So make sure you keep watching. Okay guys, you know the drill. So to start, let's create a new package. Let's call this package control. And then inside of this package, let's create a new Kotlin file called control example. And again, main function. That's where all the code will be starting to be executed from. So first, let's create a when statement. First, we'll ask the user if they want to execute a while example, an if example, do while example, or break/continue example. And then, depending what the user says, we will go into execute that example. So first, let's create the value. Now let's get user's input. Now let's do a switch statement. Actually, first let's print something to the log, to the console. So we'll just ask them to enter one of the following. So we'll do just if while do while or break or continue. Let's shorten this one. Okay. Now let's do a when loop or when statement. Do you guys remember how to do this statement? So it starts with when, and then user input. Now the body of the statement will have different branches of code. So first we will compare with if. Then if that's true, we will execute something. And then next one will be while, again execute something. And then do while, execute, and then break and continue example, and then execute. Now let's create a function for each of these examples. Let's call them first, just to make our life simpler. So function first, and function second, and function third, now, whoops, okay, first let's move these outside, except put them inside the main function. That won't work. Okay, now, we don't need these code blocks, we can just call our function from here, but if we have multiple statements, we can put them inside the code block. But we will just call the functions. Second, third, and fourth. Okay. Now let's add some section headings. If statement example. For the second one, it's going to be while. Loop example. And then third will be do while. And on the fourth one, we will do a break or continue example. Okay, so let's just check and see how our when statement works. Okay, let's run this. Now in the console we see, please type one of the following: if, when, do while, or break continue. So let's do if statement example. So the correct function got called, meaning that, okay, so let's follow the execution flow. First we prompt the user, next we read the line and store it in a variable. Next we will check when user input equals if string, and then we will execute this function. And that's what happened. So let's check the else case in this situation, just to make sure it works. So to hit the else branch of this, flow, what do we need to write? Pretty much anything other than these 4 options. So let's type hello. So, and it prints out unknown selection, and that is perfect. Alright, so for the first example, we will ask the user to enter a number, and then we'll use an if-else statements to see if the number is even, odd, or a 0. But first, let's create a function that will check the user's input is a correct number. So let's call it validate input. And then here, let's return true or false, depending if the input is a correct integer. So first, let's declare a, or actually, this function will take a parameter. Right, input, so this parameter name type. Now, in the value, let's call it parsed input, and we will use actually input is going to be a string, and then we will use a function on the string called int or null. Okay, and now if parsed input does not equal null, we will return true, so it means it's valid, and then else it's invalid. We will return false. But hey, because in Kotlin, if statement is a statement, sorry, we can actually directly return these values. So we can do return, and then we can do this function returns type of Boolean. Right, and let's also, oh yeah, we can simplify. So this parse input does not equal null is the same as this. If parsed input does not equal null, will return true, else will return false. So this if statement is exactly the same as this line. This is definitely more cleaner. So knowing the difference, let's just use this. Now, let's use this function in the if state. Let's from the user first. Please enter a number, and then let's read it. Read line, and then let's make sure it's not null. And then if it's a valid input, we will execute this code block, else this one. So in the else case, let's print out your input is not a valid number, and if it's valid, let's use an if statement. Actually, let's lift this out because we want to be able to call or to use that variable in our if statement. So let's call input equals stat, and then we will validate input, and then we'll create a variable value again here, calling int input. Knowing that it's a valid number, we will safely call input.toInt. And now for the actual if-else statement. So this if-else will have three logical branches. So if, then input int input greater than 0. The second one's going to be else if and input is less than 0. And finally, else we'll know that it's a 0, right? Greater, less than, and then 0. So we will just print out some kind of a message, telling the user that their number is even, odd, or positive, negative, or a 0. Alright, so now we have three different logical branches here that once we validate the input using the validate input function, then convert the input to an integer, and then compare integer with if it's greater than 0, less than 0, or 0 itself. We will be able to execute this. So if we don't make any mistakes, let's run this code and see what happens. So we'll now choose the if option. Now please enter a number. So let's enter 3. And 3 is a positive number. Perfect. Okay. Now for the while loop example, let's go to our function. For this example, let's make a game where the user has to guess a number that our code will initially pick. So first, let's prompt the user and explain them the rules. We'll ask them to pick a number between 1 and 5. Now let's generate a random number. We'll call our variable rand. And to do a random number, we will create a range, 1 to 5 inclusive, shuffle it, and then pick the last item in the shuffled collection. This gives us randomly shuffled list of numbers, and we'll just pick one of them. Now, we will check the user's input. So, before we can check it, we need a variable that holds it. Read line, but we'll need an integer. So let's just do int, and then so if they enter an invalid integer, this is gonna throw. That's why we did a safe check in the first example. But in this one, to make it a little simpler, let's avoid that check. Okay, so now while user input does not equal random, we will prompt them. We'll tell them to try again and prompt them for a new number. So print line, try again. And then so let's change our variable to be modifiable. Now, once this is successful, we'll print out some kind of congratulation message that they guessed the number correctly. Okay, let's build it and see what the outcome is. Well, pick a number between 1 and 5. Okay, what do you guys think it is? I'll try 3. Nope, let's try 4. Yes, 4 was the correct number. Nice. From the second guess, I got it. Great. So let's see how this works. Now, once this function gets called, we prompt the user to pick a number. Then we'll create a random number like this. Next, we will convert the user's input to an integer. And then we'll check, okay, is user's input not equal the random number? Well, too bad they didn't guess it, so let's give them a chance to try again. Now, let's read their input again and check the condition. Is it not equal? Okay, let's give them another chance. Until this condition is false. And it's only false when user input equals random. So when it's equals, we don't go into the code block. We will just jump over it and get into this line, and then we'll print out the final congratulations statement. Now for the third example, do while. So for the do while, let's create a similar game as the second one, but let's make it more efficient, because in the second example we are repeating the same line. So let's see if we can do this more efficiently with a do while loop. So how can we make this more efficient? Now, remember, the do code block is executed and only then the while condition is checked. So we'll actually move the user input inside the do, and here we will just initialize it. And then once we have the user input, we will have to check it. We will check it by comparing the user input to the random number. And also we can move this statement in order to make it a little bit more efficient. Let's run it. So let's try number 1. Oh, lucky from the first try. Perfect. Let's play this one more time. Aha, alright, third time's the charm, as they say. Okay, let's walk through the execution. So we generate a random number, declare a variable, and then execute this block, prompting the user to enter a number, and then we store it in this user input variable. Next we check, is it not equal to the random number? No, not equal. Okay, give them another chance. Then we check again. Is it equal or not? Okay, it's equal. Now let's pass the code execution forward, and then this line will print. So for the fourth example, what we're gonna do is we will actually try and do the opposite of the previous games. We will try and guess what the number the person is thinking in their head using a while loop and a break keyword. So let's prompt the user to think of a number. And then ask them if they are ready. Now, if let's do a while loop. Let's give them an option between yes and a no, and then we will, if the user's input equals to yes, we will break. Now we can move this into this loop so that we get the message every time. Now after this, let's do another loop where we will try and guess if we have a correct, if we generated the correct random number to match the user's number they're thinking of. Let's first declare a variable called random, and that variable is going to be a number in a range of 1 to 5. Now we'll shuffle it, and then get last, and then if well, first let's ask the user that to confirm that our guess is correct. And then if they're saying that the if they're saying yes or no, meaning that we guessed correct or not correct. So let's give them that option first. They can type in yes or no, and then readline equals yes. We will break. Else, we'll just continue the execution further. Okay, and let's print out some kind of message at the end, just saying out of the loop so we can see our execution. Something like that. Now, if we did everything right, it should be a fun game. So let's build it and see what happens. So I will pick B, let's see the case. Now, are we ready to play? No, not yet. Give me another second. Okay, I'm gonna think of a number 4 this time. Great, I'm ready. That's the only number you haven't tried yet. There we go. Finally, the computer was able to guess what number I was thinking of. I guess humans are still good at something. We were definitely more efficient at guessing what number the computer was thinking than vice versa. So I hope you enjoyed this example and you had fun following along, and you can definitely try your own variations of all these control flows to create very sophisticated, very smart apps and software, and then make sure you do the assignment because that one was also going to be very challenging. How's it going, guys? Alexei here again, and welcome back to Fundamentals of Programming with Kotlin course. Today we'll be talking about object-oriented programming and specifically classes. What are they, why are they needed, and how do we use them? So, in object-oriented programming, encapsulation is a very important principle. This is when you put related behaviors and properties into a single object. So complex system can be represented by many objects interacting together to solve a complicated problem. Also, objects have state and behavior, for example, functions and properties, like we've learned in previous lessons. And only now classes will contain those properties and functions into a single place, and these classes usually represent some sort of a entity, like a car, for example. On the side we have a car, so the states for this car can be moving, parked, can have a color, so it can be green, red, black, white, and then lights can be on or off, and it has 4 wheels. Now, those are the states. The behaviors are functions that change the states. For example, accelerate will turn the car from parked state to moving state. Decelerate from moving to parked. You can turn, and that will rotate the wheels. Then you can turn lights on and turn lights off, so like actions. Now, to define a class, we have to have some sort of a template, some sort of a blueprint. To create objects, right, from classes, we need some kind of a guidelines. So objects are created based on class definitions. These are encapsulation of properties and functions of an entity. And using the classes, we can create objects, instances of an object. And we can configure these instances. So, how do we declare a class? So first we need to understand that the class body contains properties and functions. Now we have to start with the class keyword and following it with a name. Then we open curly braces, and inside them we can put any properties and functions. So here we have a property called action, and then we have 2 functions that modify this property, right? This one is called run,
You already know how to define functions, so this should be pretty easy. It's exactly the same how we defined them in the past lessons. And then here we modified the property called action by assigning a different string to it. And we call it just by calling it directly, action. Now, to create an instance, we have to call the name of the class and have a constructor call here. So we'll go into constructors in a second. So because we don't have any parameters for a constructor, since the dog class does not have one, we only have empty braces here, brackets. Now, this creates a new instance, and we hold it in a variable called dog. And now we can call the functions that we define. So our class name, or our actually variable name, dot, and then function name. And any parameters that the function call takes any parameters, just like we did in some previous lessons. Except now we know how to define a class. And here you can see the classes functions are being called when we check the property. Okay, constructors. So what if you want to configure your class when you create it slightly different or pass different parameters? How would you do that? Well, this is when you need to use a constructor. It takes any parameters that you declare, and then you can do all sorts of operations with it. You can store those parameters, or you can use them to have some kind of a logic for initializing. Next, there is also, you have to use the constructor keyword, right, before your primary constructor in order to call it. But there's actually different types of defining your primary constructor. So there's a couple examples here. This is an example that uses the constructor keyword. You can think of a constructor as a function that is called and it initializes an object, right? So here we take a name and sound and type string and type string. And then we store them in local properties, local variables that belong to this class instance. Now, above is the same as this. We can actually have inline definition of the variables. So variable name and variable sound are defined using the val or var keyword, and now they're actually properties of the instance of any instance of the dog class in this example. Now, to initialize them or to do some kind of a processing on these parameters, we can have an init block, and the init block will run right after the primary constructor is invoked or is called. Next, so we can actually omit or we can skip the constructor keyword like so, and the rest is the same, or we can do something like this. Because the parameters are available when we initialize the properties, we can define these properties outside of the constructor, and then right away we'll assign the parameters to these properties. I know there are a lot of ways for defining primary constructor, but if you pick one, pick the one that's the least verbose, like the smallest implementation, and stick with it. Be consistent. Because a lot of times Kotlin gives you too many options, and you have to pick one and stick with it. simply so that your code is consistent across time, and it's easy to any developer to jump into it and figure things out. Now, secondary constructor. This is when you have a default constructor and also a secondary constructor. So why would you need two or more constructors for a class? Well, that's because sometimes you want to have different parameters than the primary constructor takes. But it's important to keep in mind that the primary constructor will also get invoked after, before the secondary constructors are called. So this is needed so that you have consistent code that initializes the class, but then you can add extra parameters, right? You want to have your required properties to initialize, but then you can have the user provide something extra. So in this example, we have a default constructor that takes name and sound for this dog class. But also we have a secondary constructor that takes name, sound, and age. And then in this block here, in the constructor body, we have some sort of an operation on the parameter that we take, and we store the parameter in the property of this class. Now, next. This is how we use it, right? We can create one instance of this class with only two parameters, and then next we can create, next we can create a instance of this class with a single parameter, but this is still calls the primary constructor and uses the default default value for the sound parameter. To define it, we do equals and then default value of the correct type. And finally, this is how we call the secondary constructor. So string, and a number, which is the signature of this constructor. String, and a number. Now, visibility modifiers. What are visibility modifiers? They are keywords that let you have certain functions and properties private. And why would you want to have private functions? Well, because sometimes you don't want to expose some kind of functionality to external code that's outside the class, because calling those internal functions might break some kind of state in your class. And this is very common, where you have public functions and properties that any class from outside can call, and then you can also have private that are only used inside the class. And the other two we won't have to worry about for now. So public, when you use the public keyword, the property or function is visible everywhere. Private, only visible inside the file containing the declaration. Now, this is how you use this modifier. Remember how we defined the property before? Now we can declare the name property as a private property of this class. So only this class can use it, and no one from outside of it can. And this is an example. We create a new instance with two parameters for the primary constructor. Then when we try to call the name property, it will not compile because it is private. Okay, and now it's time to apply what we learned and write some code. So stick around. So you guys know the drill. First, let's create a new package. let's call it object-oriented programming. And it's inside this package, let's create a new class. Let's all call this class object tests. Okay, and let's create a new function. Perfect. Now, before we start doing anything, let's create another folder. Sorry, another package. Let's call it objects. Or let's actually call it classes. So here we're gonna put all the classes that we define. So let's get started. Let's create a new Kotlin class. So here instead of file, let's actually pick class. And let's type car. We're gonna create a simple car class. So as you can see, this IntelliJ Studio generated a class, a simple class for us called car. You can see the class keyword, and it's inside the package object-oriented programming.classes. Now, we want to create a car. Let's think, what kind of properties does a car have? So a car has color. Let's make it a value, right? So we want to define it once and not change it afterwards. Type string. Now let's define as well car type, or like car make, which is also going to be a string. Perfect. Also, now let's create a field with some default values. So for example, car seats, right? Car can have 5 seats, that's going to be a sedan, or it can have I guess 7 seats or 8, and that's going to be a minivan. So let's create now let's create a secondary constructor. It will take the same properties, color, make, but also it's gonna take seat count. So by default, we're gonna have a sedan. If the value is provided, we're gonna create a minivan. And it will be integer. Okay, now we have to remember, we have to call the parent constructor before, to make the secondary constructor work. So this is the syntax, semicolon, and then this, open brackets. And these brackets will take these parameters, color and make. We already have them passed to the secondary constructor here. Color and make, the first two. Now, what do we do with the seat count? Well, we want to do this, referencing this instance of the class. Now, equals seat count, which is this value. Now, we have a problem, right? Because we made it value, we cannot reassign it. So we'll have to make it a variable. Now, perfect. So let's see what happens when we call the secondary constructor. We'll have multiple values. These values are passed to the primary constructor that then sets them to color property and make property. right? So these will become fields, instance fields, like properties belonging to the instance that we'll create of this car class. And now let's call this. Let's initialize it and call it. Let's go back to our objects task class, and let's create a new instance. And this will be the car that's the color green and make of Honda. Now, let's print it out. Okay, perfect. Now let's make another instance, right? Because that's the whole power of objects and classes, that we can make different instances with different configurations. Now, for the minivan instance of the car class, we will pass the color, the make, and seat count. So let's say 7 seats, I think the minivan has. And let's print it out. All right, and let's run it. So it prints out car, Honda is green, minivan, Honda is gray. So what happened? I made the typo here. This should be a minivan. Okay, let's see that fixed page. Okay, minivan Dodge is gray. Perfect. Okay, next, let's have some logic. Let's put some logic into our class. So instead of us creating a string, let's create a description string function. So we'll call it describe, and it will return string. And what we'll do is we'll return, depending if it is 4 seats or more than 4, we'll say sedan or minivan. So we will return a string saying make of the car, type, sedan or minivan, depending on the seat count. So anything less or equal to 4 will say sedan. Everything more than 4 will say minivan. And now let's call that instead of our string templates in the object test class. So we'll just do car.describe. And here we'll do minivan.describe. Let's see what the console will print out now. Perfect. Honda sedan is green. Dodge minivan is gray. Okay. Now, what if we want to be able to have some kind of a logic and only be able to call it from within the class? Okay, so let's create a property, revolutions per minute, RPM. Now let's create a function that modifies the revolutions per minute. Okay, let's make another function that also modifies. So what we're doing here, we're subtracting, but we don't let the RPM get into negative territory, and then we'll set it to 0 if it is below 0, less than 0. Okay, let's try this. Car dot press gas pedal. Now let's press it twice, and now car dot press brake pedal. And let's see what the velocity is of this car. A 100. Yep. So we increase the RPM twice. So 100 plus 100 to 100, and then we decrease it by 100 by pressing the brake pedal. But what if we don't want to be able anyone modify the RPM other than these functions? What I mean is, see, we can modify it here, right? And we wanna prohibit that, right? This won't make sense. We don't wanna expose this property to outside classes. So how would we change that? So do you guys remember the visibility modifiers? We would add private visibility to the RPM function. Now we are not able to modify it, but we're also not able to read it. So what do we do if we want to read it? Right? So there's a few options. First is we can create a simple function called getRPM, which will return RPM. And of course, we have to add the type. Now here we can just do a car get RPM, and this will give us exactly the same output as before. Perfect. But this is a little bit there is a simpler way to do this. So what we can do is we can actually modify our property. So we'll remove the private modifier, but what we're gonna do is we're gonna type private set. And that's it. So the RPM is accessible from outside the class, but the setter for that property is actually private. So the way properties work in Kotlin is they're actually, under the hood, getter and setter is generated. a getter returns the value and a setter sets the value. But declaring the property in a class is enough. But then also you can modify your setter private. And you can also have some extra logic for working with the value and the field, the backing field of this property. So field equals value. This will be default implementation, but when this setter gets called, you can also have some extra logic. So for example, so let's print this out and see what happens. Oh, actually updated 2. RPM was updated 2 and the value, the current value. Now let's see what happens. Let's run it. And we'll see 3 console logs that we just created. RPM was updated to 100, was updated to 200, and was updated to 100 again. Okay, and that will be it for this hands-on part of this lesson. You learn how to define a class, how to define properties, and how to set them from the constructor or how to set them from the constructor's body, right? And you learn how to create secondary constructor that passes data back to the first one, always. Next, we learned functions within this class, how to define these functions, how to make them private, or how are they public by default. And then we learned a little bit extra about fields and privacy, setting fields or setting properties to private. And we also learned how to define different instances, right? Name, and then we call the constructor with the parameters. Learn how to call secondary constructors and how to call all the functions. And please do the assignment for this course, because getting a hang of this concept, the object-oriented concept, is extremely important. Hi guys, Alexei here again, and welcome back. In today's lesson, we will talk about inheritance, composition, and casting. So, inheritance and composition, what are they? And when are they used? So basically, these are super critical concepts to understand because most of the code you will write, you have to consider inheritance and composition. And in order to solve really complex problems, you have to know how to compose the classes you're gonna write. So complex classes are usually a combination of both inheritance and composition. And inheritance is when an object inherits properties and functions from its parent, right? Just like in the real world. A child will inherit some properties from the parents. Composition is when an object is composed partly of other objects. So for example, a house is composed of many rooms, like bathroom, bedroom. It's composed of elements like stairs, windows, and then a house is a parent of a building, and a building is a house. So both of them are structures that contain people inside and contain rooms. So their behaviors and their properties are very similar, but a building will be a bigger house. And there's slight differences between these two. That's why building inherits from a house, and the house is composed of other elements. Composition. So to create complex functionality, you can combine many simple behaviors, right? like a car is composed of wheels, frame, doors, and engine and transmission. Then behaviors are made up of classes, functions, and properties. And behaviors can be reused by different types of classes, right? That's why composition is so modular, because you can reuse all the components. So here's an example of composition. We have a couple components. We have a wheel that can rotate. We have an engine that, depending on the horsepower, will apply torque to the wheels. And then we have a frame that has a color. Now, how do we make a car out of these components? We have a car with a constructor that takes a make, an owner, and a color. Then we have a list of wheels, 4 wheels. Then we have an engine that's 120 horsepower that's creating this object. And then finally we have a frame that takes a color that we passed in from the constructor. And that's how we compose a car or an object from multiple components. Next, inheritance. Now, inheritance is a little bit more trickier to understand than composition. Derived classes inherit from properties and functions from the parent class. For example, we have a person who can talk, walk, eat. Then, math teacher inherits from the person and can teach math. Play football, footballer can play football and also inherits the properties from person. And then the businessman runs a business and then inherits the other properties from person. And behaviors can be reused via inheritance, right? So as you saw, businessman, footballer, and math teacher share the same behaviors as a person via inheritance. So for example, we'll have a parent class, and to declare a class that you can inherit from, you have to use the open keyword. Then we'll declare a class normally, the class keyword, and then the constructor. So in this example, we'll have a class called a vehicle, which has a list of wheels, an engine, frame. So this vehicle has a drive function, and then a horn function that can be overwritten by a child class. And to make it overwritable, we have to specify an open keyword before the function signature. Now, to inherit from this class, we have to declare right after the primary constructor in the car class, we have to have a semicolon and then specify the parent class that we want to inherit from. And the parent class, from the parent class, we will overwrite the horn function. We'll provide our own implementation. And so once we do construct a new instance of a car class, we pass all the parameters. Now we have access to the drive function, which was inherited from the parent class. And if we call the overwritten function, it will print the string that we provided. And that's how the inheritance works. So you might still be confused what are the benefits of inheritance over composition. You'll see in just a couple minutes of all the power that inheritance has over the composition of objects. So casting. Sometimes when you're coding object-oriented ways, you have to check the types of the classes. So to check the type, you can use is keyword. And Kotlin is a great language that makes your life as a developer much easier because it has a lot of smart cast features. So when you check a type of an object, right after that check, the object will be cast explicitly cast to that type. So children can be downcast to its parent type, and this is very common when you want to share common behaviors or expose shared behaviors from the base class, even though the derived classes are different. For example, a button can have an on-click function, and then also a checkbox can have an on-click function. Even though they're two different classes, you can downcast them and only expose that on-click functionality of their parent class, which will probably be a view class. And you can also explicit cast using as keyword, but explicit casting is not as common as implicit casting using the is keyword, simply because explicit casting is error prone. Now, here's an example. Following the previous example with the vehicle class, let's create a couple more subclasses. So let's create a truck, and the truck will take a color, a load, and the load is a class that's defined like this. It's just a regular class that takes a weight parameter. And now that we have a truck and a car from the previous example, we can create both of the objects, create the instances like so. Next, we can create a list and store both the car and the truck, even though they're different types. And we'll store them as a list of vehicles. They're shared parent class type. So remember, the collections in Kotlin, they are type safe, and you can't store different types of objects. They have to have similar type. So we can store car and a truck even though they're different subclasses of the same parent class. Now we can iterate through each vehicle in the vehicles list. We can call functions on those instances of the vehicles, and we can also check using casting. As you can see here, we're using is keyword, so we're checking, is vehicle a car? If so, let's print out the string. Else, is vehicle a truck? Then we print out the string. And finally, let's see, this example will print out the following output. And it differentiates properly between a car and a truck using casting. Okay, and now let's apply the new things that we just learned in code. Okay, so let's get started. First, let's create a new file in the object-oriented programming package we created last time. Let's call this file inheritance example. And again, let's create a main function. Now, let's create a person class. So that's going to be our base class. Let's create it under the classes folder, where we kept the classes from the last lesson. And this will be the type of a class, and let's call it person. Now, what kind of properties does a person object have? So first name, last name. Okay, so let's think what kind of functionality this class can have. So a person can walk, and then they can also study, then also sleep, Now let's implement the study function by having a private property that will increment every time someone studies. So we'll call it knowledge. And it's going to be type of integer, initialized to 0. And then when someone studies, we'll increment this by 1. Next, we'll create a property for sleep that's called resting, and we'll make that property private. And finally, let's create a function called morning. That's where a person's going to wake up. Or actually, let's call wake up. And finally, let's create the last property called walk. Or is moving. Let's call it is moving, and then when someone's walking, we'll change this property. Now, and to finish off that action, let's also have a function that's called stop. And there we will stop moving. Equals false. Okay. Now, obviously, when someone's sleeping, they cannot be moving at the same time. So let's add that change here as well. And then let's assume when someone wakes up, they start moving right away. Now, that's the base class from which we will extend all the children classes, all the derived classes. So let's create those. So let's create a new Kotlin class. Let's call it student. So what a student will do, well, we have to inherit all the behaviors from the person class, right? So to inherit, first we have to have a semicolon, then the class we want to inherit from, and then we have to call, pass the parameters to the parents constructor. So, and the parameters from the student constructor have to match, or you have to provide the static parameters to the person. So for example, person takes first name and last name. So therefore the student also has to take first name and last name with the same types. Oh, so one thing we forgot in the person class, we have to make this class open so that all the derived classes can actually inherit from person. So now the student has all the functions and all the behaviors that the person class has. But we also want to allow student have some extra behavior that the parent class does not have. So in this example, let's make two functions. We'll call them go to school and go home. And the go to school function we will implement by calling wake up on from the parent's implementation of this function. Then we will call walk, and then we will call study. Then for the go home function we will call walk, and then sleep. And actually let's also add a stop function to the parent, to the go to school, and then also walk and then stop for the go home function, so that when the person's walking then they stop. And like so we were able to reuse the functions in the parent class by inheriting them from the parent, which is person. And the properties like first name and last name we can still access from the parent class because they are declared as they're declared as values, right? Values that live within the instance of this class. So we can have access to them. But we cannot access the private ones because they're private only to within the inner functions of this class. Okay, let's create another class, and let's call it athlete. So again, this class will inherit from the person class and pass the parameters to the person constructor. So in this class, we will override the walk function, meaning we will provide our own functionality. So to do that, we have to write override keyword first before writing the function name, which will be walk. So you can see here, walk in person is final, cannot be overridden. What does this mean? It means that when we declared the walk function, we did not specify the open keyword. And that only if we specify a function with an open keyword, only then we can override it, right? Remember, the same with the class. Now, there's no more error, and we can override the walk function. And what we're gonna do here is anytime you call walk on an athlete, we will call a private function called run. And then we'll have a field representing this state. I will make it a Boolean. And now whenever this function is called, what we're going to do is we're just going to toggle. We're just going to change from true. If it's true, we're going to change it to false. If it's false, we're going to change it to true. Remember this operator from the past lesson. Now, let's try and use all the classes that we have defined. Let's create a list of people that which we're gonna populate with the instances of different types of people. And it's gonna be a mutable list so that we can add more items to it as we go. And this will be a type of person. Remember, we can downcast athlete and the student to their parent class. Now let's create some instances. Now let's create a student class, instance of a student class. And now let's create a instance of the athlete class. So even though there are different types of class, but because they have the same base class, student is a subclass of person, and then athlete is a subclass of the same, we can add all of them to the same list, because that list is type of person. Now we can iterate through this list. And let's rename the list to people so it's more appropriate. Now, let's use casting and type checking to write us different messages in the console depending on the type of the person that's in the list. To do that, what we want to do is we want to check the type of the person by using the is keyword and then the type of the class. And now let's write the message. And now let's see what kind of output we're gonna have. And as you can see, we have correct output, right? So it says Joe is a regular person, because Joe is just a basic implementation of the person class. Then Bob is a student, because we were able to check that this instance of the student class was type of student. And then Tom is an athlete, so that instance of the first name Tom was an instance of the athlete class. And now finally, let's call some functions on these classes to see what we cannot do. Right. So remember, we overrode the walk function in this athlete class. So let's call person dot walk, and now let's see what will happen. But first, let's change the visibility of the field of the isMoving field. Let's change its visibility a little bit. So let's make the getter public and then the setter private. So do you guys remember the syntax for that? Now, to have the getter public and the setter private, we have to declare private set, like so. And now we will only be able to get the isMoving and not set isMoving from outside of this class. Obviously, we can still change isMoving from inside the class, right? The visibility modifier applies only to the outside. Okay, and now let's print out some information to the console. Right, and also let's change the visibility of the isRunning function so that we can debug it or print it to the console. Right, let's make the setter private and we can still read it. Right, now we can read it, and actually these are Boolean values, so let's do this. If person is moving, let's say else, let's say and we forgot to override the stop function in the athlete class. So let's override. And that will change two things. So actually first let's go to the base class and make the stop function open so that we can override it. Now let's go back to the athlete class, and then isRunning is going to be false, and then we should also call the parent function, right? And to call the parent function, we actually do it through this syntax. So we have to say super and then the function we want to call. And like this, we will be calling the super function. And let's also do this. Actually, no, the stop function is good enough. So whenever the athlete starts running, we will toggle isRunning. Okay, first, before we run this, let's see if you guys can spot any problems with this logic. So first problem is actually we made a typo here. Person is running, else person is stopped, right? Now also, let's have a else statement here where we're gonna cover this. Just all people other than athletes. We will handle in that else statement. And finally, let's modify the athlete class a little bit. So what we want to do is we want to actually change the run function a little bit. So run function should modify is moving. Is moving equals true. But there is a problem. We cannot reassign is moving. So let's go to the person class. And let us tweak it a little bit. So the private, the setter is private for the is moving. Whenever you cannot set is moving from outside. But let's allow the setter to be called from the subclasses. So to do that, we'll use the protected keyword. And that will still allow us to call the setter from the child classes, but not from outside. So our main function won't be able to change it. Only the children and the actual class itself can modify. And finally, let's just change the run function to not toggle is running app, but just to set it to true. And that should fix all the issues. And now let's run this. Let's run this function and see. Okay, so when we run it, we'll see, okay, for each person in the people list, we'll print out their type. So Joe is a regular person, and then we'll call walk, and then we'll check the state, right? So Joe is moving. Then Bob is a student, and then we'll call walk, and then the Bob is moving. And finally, for Tom, he's an athlete, we'll change, we'll call walk. And remember, we overrode the walk function in the athlete class. And whenever you call walk on an athlete instance, they start running. And that's what we're printing here. Person Tom is running. And that's it for this example. I hope that you've, it's a little bit more clear for you now how to use both inheritance and composition in your code. As you can see, we composed the person class of multiple components, and then we modified their visibility by the visibility modifier keywords. Then we were able to inherit from that base person class and also modify its functionality and reuse some of the existing functionality like we did here, right? And we were able to override like we did here and compose using more components, right? Like the is running keyword. And that's it for this lesson. I hope you enjoyed it, and I'll see you in the next. Alexei here again, and welcome back. In today's lesson, we will be looking at abstract classes and interfaces. So let's begin with an abstract class. In the previous lesson, you've learned how to create a base class and inherit from it. Well, an abstract class is a specialized base class that provides partial implementation, but is not directly instantiatable. You cannot instantiate it. You cannot create a new instance of it. So then the class also can provide functions without a body. So abstract functions that are not implemented. And only the methods or the function signature is declared, where the child class has to implement that method. So abstract classes are really useful for creating some sort of a template that has partial implementation that's shared across all the children. And the children have to provide the rest of the implementation. So here's an example. This is how we define an abstract class. We have the abstract keyword, then we define the rest of the class normally. And then we can have abstract fields as well as abstract functions. So as you can see, this field, I did not have to initialize it with any integer value. And as you can see in this function, I did not have to write the function body for it. The class, the subclass of GameObject will have to implement the abstract behaviors. So also one thing to mention, that abstract classes don't have to be open, because abstract class by default is open, so that any class that you declare abstract can be inherited from. Okay, so this is the player class, and here we have again, we inherit from the GameObject, and then we have to override. We must override the abstract behaviors. So here we are overriding health and providing the initial value, and we're overriding this function on laser hit, and we're providing the implementation for it. Now, here's another example of a subclass of a GameObject. We're overriding the same abstract fields, and we're providing our own implementation. And finally, once we use those classes we just created, you can see we cannot directly initialize GameObject because it's abstract. And then the child classes that inherited from it, we can initialize. Now we create a list of game objects with the player, enemy, and second enemy. And then what we do is we go for each object in the game objects, hit it with a laser, and then while the enemy's health is not 0, keep hitting the game objects with the laser. So it's a very simple command line based game. And finally we'll print out the winner at the end of the round. And in this case, the winner of the round was Jim with 340 health. Now, an interface. An interface is a very similar concept to an abstract class, except interface cannot have any implementation. So an abstract class could have some implementation, interface can't have any implementations. So an interface is basically a class that does not have any implementation and only has method definitions or function signatures. Class can implement many interfaces, but only inherit from a single parent. So that's one advantage to interfaces. In most programming languages, there is no such thing as multiple inheritance. You have to go around it either using composition or by having implementing multiple interfaces, which is often how it's done in Kotlin. And so also interfaces that used to force a certain behavior or a class to adhere to certain guidelines. Sometimes your functions can accept a certain class that implements a certain interface just so that you can have some kind of contract that will tell you, hey, okay, these classes have certain functions that I can call without you having to know any implementation or any more details about that class. So let's see how to use the interface. So here we define 4 interfaces. To create an interface, we have to start it with the interface keyword, and then the name, and then the function signature, right? So a function without the body. Same here, right? So we define 4 interfaces. Now we have 2 classes, right? One is a class soldier, that will implement three interfaces from that we just defined. So soldier will implement fighter, shielded, and laser shooter interfaces. And soldier must override the functions that were declared in those interfaces. So a soldier will have a shoot behavior, raise shield behavior, punch, and kick behavior. So these two behaviors, punch and kick, are from the fighter interface. Raise shield is from the raise shield interface, and laser shoot is from laser shoot interface. Now, jet plane implements three interfaces: flying, shielded, laser shooter, and it overrides shoot, fly, and raise shield. As you can see, some of the behaviors are shared, but the classes provide their own implementation of it. For example, shoot and raise shield. Then jet plane can fly, soldier can't. Soldier can punch and kick, but jet plane can't. Alright, and now, in case you're still confused, let's see how we'll use these concepts in real life. And let's get on to the hands-on section. Okay guys, so for the example, how to use abstract classes and interfaces, we actually will make a little game. A turn-based game where the main character is gonna encounter various objects and then either increase his health or decrease his health, and seeing how far you can get in this game will be fun. So to get started, let's create a new package under our object-oriented programming package. Let's call this package board game. And then now inside this package, let's create a new file. And we will call this the game loop. Let's capitalize it, game loop. Here we go. And here we'll have our main function. Now, let's create another package with all the game objects in it. We'll call it game objects. And then, inside the game objects, let's create a base class, which will be an abstract class. So, do you guys remember how to declare an abstract class? Yes, we have to use abstract keyword before the class declaration. So a base game object will have a name, type of string, and then we will have one abstract function. Remember, to define an abstract function, we have to start with keyword abstract, then define the function as normal. And normally you would, and this function would be called interact with. And here we will take another game object. So we'll implement this function whenever every game round for all the game objects, we'll implement their interaction inside this function in the children objects that will inherit from this class. Right, and this function does not have an implementation. Now, function that will have one more function, but this one will have an implementation, and basically this one will just print the name of the game object to the console. Okay, let's create another game object, and this one will be called the main player. We'll we'll make it a class, and then we'll inherit from base object, base game object. Now remember, we have to provide a name, and we also have to implement all the functions of the base game object interface, right? So what we're gonna do is leave this function unimplemented for now until we have all the other objects implemented, and then we'll come back and finish this function. But first, let's create an interface. Let's make a type of interface, so this dialog generates the interface keyword for us. And now let's call this, let's just call it health let's call it with health. So with interfaces, we can create functions that are not implemented, and the child will have to implement it, but also we can have declare properties without implementation or without the default values, and then the child will have to provide the implementation for those properties. So here, let's create a variable called health, type of integer, and we don't have to give any default value. Now, let's create a function, and also we will create a function that will be called try decrease health. And we will call this function whenever a game object tries to decrease health of this current game object that will implement this interface. For example, whenever an enemy encounters a player. And we're also going to pass a power level to this function, which will be integer. Okay, now let's actually have the main player implement this interface. So to extend a class and implement an interface, what you need to do is separate them with commas, like so. And then we can implement the health attribute and then the function from the interface. We'll start with the default health value of 100, and we'll come back to this implementation of this try decrease health function in a second. So let's create a class. We will call it weapon class. This is going to be a generic weapon we'll be using throughout the game. So weapon will have a name and will have a power level. And this class will just have a primary constructor, and that's it. No other functions or anything. Now let's go back to the main player class. We will go back to the main player class and then create a new field to hold the instance of our weapon for this player. And we will start with a basic weapon. Just call it basic stick, and we will give it power level of 10. Now let's create an enemy class. We'll call it enemy, and it will be type of class, and it will also have a name. And it will inherit from the base game object. And we'll have to implement the function. And we're also going to have health and a weapon, just like the main player. And we have to implement the health interface for this too. And then the decrease health function. So as you can see, both of the classes are really similar, and we have a lot of repetitive code. So to kind of eliminate repetitive code, we can have another base class or another abstract class inheriting from the base game object and having this behavior in it to kind of avoid repetitive code. So let's do that. Let's create a new, let's just call it player object, type of class, and we'll move all of our repetitive implementation into that class, and we will make it abstract because we still want the enemy and the main player providing their own implementations. And we'll remove well, we actually don't even have to implement the interact with and the decrease health functions here. And again, let's fix up the enemy class. Again, I will implement from the new class we created as the name to the constructor, and override or implement the methods. And exactly the same for the main player class. All right, and now we can actually begin implementing the interaction and the function that takes the damage. So for this game, the only time we can incur any kind of damage is when the power level is greater than our own power level. So let's do this if statement. If power level of the parameter is greater than our power level, so to refer to our power level, we actually need to have a power level for this the base implementation. So actually, let's add the power level. Well, let's begin with 10. And with every level, we will increment the power level of this entity, of this game object. So again, if power level is greater than our power level, we will incur damage. So we'll decrease the health by 10. And then if our power level is greater than the enemies, then nothing's gonna happen. Okay, so interaction. We should also implement the base game object interface for the weapon, because we will want to be able to use that in our interaction function. And let's implement the function. And then for the weapon, when it interacts with another game object, we won't do anything, no implementation, because the game object itself will interact with the weapon. Okay, so first, for the main player, when it interacts with the game object, so let's check the type of the game object. So if other is enemy, what do? We want to try and decrease the health of the enemy. So we'll try decrease health. By how much? So we will try and decrease it by the power level of our weapon. So we have access to the weapon, and then we can read the power level. Next, so if we encounter, or if we're interacting with a base game object that's type of a weapon, we want to check if the power is greater than our current weapon, and only then we will take that one. So let's check the type. Then we'll check if the power level is greater. And only then we will take the reference of this. Right, so far we only created two other game objects, enemy and the weapon, but let's also create the health potion. Again, base game object. So again, with this, the health potion won't interact with our game objects, only the game objects will interact with the health potion. So there's no implementation for this method. And the last thing for the game potion, for the constructor, we want to take the health amount that the potion will replenish. All right, and now for the final check, going back to the main player. So let's do else if other is a health potion. Only then we will increase our health. Okay, and now let's implement the enemies functions. So the enemy will take damage from the main player no matter what. So we'll just go ahead and decrease the health. So we'll do health itself minus power level divided by 100 times times 10. So just like a standard multiplier. And we may have to make sure that everything's afloat so that we have nice rounding for this value. Okay, and finally, the enemy will only be able to interact with the main player. And the way it will do that is it will try to decrease the health of the main player. So we'll do if other is main player, and we will try to decrease health, and then we'll pass our weapon dot power level. And finally, we want to modify the constructor of the enemy to also take a weapon parameter, so that when we generate the enemies for every game loop, we can initialize it with a certain power of a weapon, but for a game player, they'll have to level up their weapons. So one thing we have to modify is we actually have to change the weapon to be open so that we have to add the open keyword so that we can change it. Right, and it's a variable. So we can actually move that declaration directly into the constructor by doing that. And now let's create the game loop where we're gonna go for every round and then have the game objects interact with each other. Now let's prompt the user to enter their name so that we can assign it to the main player. Now we can initialize the main player with the name. Now, in the main loop, we want to generate an enemy with a random power level that is a little bit less than the main player to kind of make it more interesting for our game. Now let's create, initialize the game enemies instance. And remember that takes a name. Let's call it a troll. So we'll be battling trolls. And now let's initialize a weapon. And then the weapon has a name and a power level. Again, so name, we'll give it a name stone or something. And then power level will be the power level we just generated. Right, so we have to grab we have to shuffle our list of numbers, right? Because we generated a list of numbers from 0 to power level. Then we have to shuffle and then grab last. Right, this is how we get a random number between 0 and the power level of the current player. So actually, let's do between 0 and power level -1. Yeah, so let's do 0 until power level -1. Power level. Now we can do the interaction. So the enemy will interact with main player, and then main player will interact with the enemy. Now, so we also created two other items, a health potion and a weapon. So now let's have a function that randomly returns us a weapon or a health potion. So if the random function gives us 0, we will return a health potion, else we will return a weapon. So this way the player has a way to level up after every round. Okay, and that's how we create a health potion. Now let's create a weapon. So to make it more interesting, let's have this function take a some sort of a multiplier for the let's say level. Like depending on which level we are, we'll generate better and better health potions or weapons. Okay, and that's our get random game object. So now let's get the random game object inside our main loop. And then let's create a variable that counts our levels. And let's remember to increment the level variable by 1 every round. And then assign this game object to the main player. So interacts with, main player interacts with this random game object. Now let's see how this game runs. Oh, actually, well, before we run it, let's print out the stats for this level. Let's add a little bit of text. Okay, so we have added a bunch of prompts uh, to notify the game to notify the player of the fights with the enemy in the game, and then what their new health is, and then if they found any exciting game objects such as health potion or a weapon. So let's run this main function and see what happens. So let's enter our name. So level 1, player encountered a troll, a level 2 troll. Player health decreased to 100. So the health, the troll hasn't done any damage to us. Then the player found a weapon, ready for next level. So let's format this a little bit better. Okay, there we go, print line. So let's run this again. Okay, similar thing, ready for next level, hit enter, ready. So doesn't look like, well, we found a potion and our health increased, but doesn't look like the trolls are doing any damage. So let's fix that a bit. Okay, so let's increase the power level of the enemies a little bit in this game. So let's go back to the game loop and let's multiply the power level by the current level of the game. So when the enemy's weapon is initialized, it's a little bit powerful and more powerful with every level as we go. Okay, so let's run this again. Okay, level 1, health decreased to 0, and then okay, ready for next level, health decreased to 90, then player found a potion, health decreased to 108, level 18 troll, ready for next level, and it looks like our player has been killed by a really powerful troll. So let's print out some kind of message here. Okay, and let's see what this will look like when we run it. Let's see how far we can get this time. Okay, and level 0 troll, alright, interesting. Okay, level 56 troll, your health is at 117. Okay, so let's make the trolls a little bit more powerful. So let's change the range in a slightly different way. So let's do from level until the main player's power level. So we're gonna get more and more powerful trolls, and then we'll multiply their level. So let's see. So to kind of make the game a bit more challenging, you can play around with all these parameters and values, and you can add any other types of game objects that you can think of, and you're free to customize this game and make it more fun and exciting as you see fit. And I hope you enjoyed this lesson, and I will see you in the next one. Bye. Hi guys, and welcome back to the Fundamentals of Programming with Kotlin course. And in today's lesson, we will be talking about data classes and Kotlin object classes. So let's start with data class. This is a very useful tool in Kotlin for creating a class that only stores data. So these classes are usually used as data model classes, meaning they're there to store data, and they're used to model some sort of screens or behavior or users or any kind of data. And usually they don't have any extra functionality other than equals, hashcode, toString, and copy functions. So to create a data class, you have to mark it by data keyword right before the class keyword. And the functionality is automatically created by the compiler. So here's an example. We have a simple data class called employee that has a first name, last name, and age, and all of these have to be specified in the primary constructor. Then we can use this class like so, right? We call the primary constructor of the employee class, and we pass first name, last name, and age. So we have 3 employees, but employee number 1 and employee number 3 have the same first name, last name, and age. So because we have a synthesized equals function, so equals function is called whenever you do equal operator on an object. So because we have a equals function, we can compare. So we'll compare second and third, they're not equal. Then if we compare first and third, it prints true. So equal will usually compare, by default will compare, are the instances the same? But in a data class, equals also compares the fields. So is each of the field equals to the other object? And this is very useful sometimes when you're downloading data from the server or from an API, and you have similar data structures or the same data models, but they came from different responses, and you want to compare if the values are different. And you don't have to write out the comparison field by field, and this is a really useful feature in Kotlin. Now, Kotlin object class, not to be confused with just plain objects in object-oriented paradigm. So what is a Kotlin object class? So these are very unique classes or very unique concepts to Kotlin, and you can use them as a declaration or an expression. Meaning, when you use it as a declaration, it's useful for creating a singleton pattern, which is a single instance across entire application. And that is sometimes useful to hold some kind of a state or constant data across the entire application, across multiple instances of all the classes. Then we can also use a Kotlin object as an expression. when used as an expression, we'll usually create an object that is a slight modification of a class without having to create a subclass or write out full inheritance declaration. And this can be useful in event listeners like onClick once we get into UI, or any kind of small modification of a object. So let's look at some examples. Here is an example of object expression. So we have declared an animal class. It is open so that we can override it or we can inherit from it. And then it has a one function, make sound, which returns 3 dots. Now, what if we want to modify this function or overwrite it, but without having to subclass, without having to inherit animal, right? We can do that, and we'll do it by writing object semicolon and then our implementation of that class. So animal, primary constructor, and then we will override that function and provide our own implementation. So here we're overriding make sound and returning the string wolf. So when we print out the wild animal make sound prints 3 dots, that's the original implementation up here. Then when we print out dog make sound, prints out wolf. So we were able to successfully override the function without having to subclass. And you should use this approach with a lot of caution because it can create a lot of messy code. Now, an object declaration. Remember, these are mainly used for singletons. And what is a singleton? Well, here's a really good example. So we have a game world object, starting with the object keyword, which just contains a list and then a print all function. So whenever we want to call a field or property and a function on this game world, we don't have to create a new instance. So it's a single instance which we can access from anywhere. And this can be very helpful for holding some kind of a data, consistent data across the entire application, or having some kind of a central point for multiple components talking to each other. So something like a communication channel of some sort. So, and here we're able to call properties and functions on this game world object without having to create a new instance. Okay, and finally, a companion object. So a companion object is simply an object that is nested inside of a class. And this is similar to static fields or static functions in other languages. And this is mainly used for sharing data across object instances or providing some kind of a constant definition or utility functions to classes outside the class this companion object is declared in. And let's see how we will use it. So for example, we have a class called robot, and it takes a type integer, and then we have a ID which will increment instance count. But where is instance count declared? So it's declared inside the companion object, which is shared across all instances of the robot class. So whenever we create a new instance of a robot, we'll increment instance count, which we can easily access by just calling it directly. And then we also have a few type declarations. And then we have a format function that just prints out the name of a robot. And let's see how to use it. So first we'll create 2 instances of a robot class. First will be robot type builder, and then second will be robot type of unknown type. Oh, just some number that's not inside our constant. So first let's print out the formatted name of robot. So robot.formatName, and takes a robot instance and prints out robot1b. Then next one, we'll print out, when we pass robot2, and we'll print out robot2x, right? Because different types will create different formatted names. So these are useful for having some kind of utility functions that are belonging to a specific class. And this could have been stored in any object, right? A Kotlin object. But having it inside a companion object is just more, it's a better encapsulation of this functionality, assigning it to the specific class. And finally, we can print out the instance count, which will print out too. It's a pretty interesting concept to master because you have shared variables across all instances of your code, and that can give you a lot of power for creating really interesting code. All right, and these concepts can be a little bit confusing to wrap your head around, but applying them and writing some code can definitely help. So let's try. For this lesson, let's create a new package inside our, let's create a new class inside our object-oriented programming package. And let's call that class a objects example, or Kotlin objects example. Okay, let's make it into a file. All right, and then main function. All right, and now let's declare some data classes. So let's create a new data class inside the classes folder. So let's call it order. Let's just call it order. And let's create the second one. Let's call it order item. Okay, so we'll have an order object that contains multiple order items. Just a simple example how to use data classes. So to create a data class, we have to have the data keyword right before the class declaration, and then we must have a single item in the constructor. So let's give this order item a name and then a price. So it has to be a var or val parameter. Okay, and now let's do the same thing for the order class. We add the data modifier to the beginning, and then we have to make sure it has a single parameter in the constructor. So it's going to be a list of order items. And now we can generate some instances of order items and fill an order list. So let's try it in our main function. Let's give a name to this order item, and let's give the price. Now let's create one more item. And let's give the price. Now we can add these to the order data object. And we'll use the list of utility function to generate a list, and we'll pass to order items. And let's loop through, well, let's print out the order and see what it prints out. And as you know, the toString is generated for any data class. So this will have a formatted string when we call print line on this order data class. And as you can see, it printed out our order, and then it listed all the items in this order, and all the strings were formatted. And we can also do a comparison on the objects. So if we by any chance have a similar item in our order, and we try to compare, so by similar items, I mean items that have the same primitive types in its properties. And if all of them equal, then the equals function will also return true. So let's try that out. And as you can see, the console outputs true when we compare order item and order item 3. Okay, now let's talk about Kotlin objects. Let's create a Kotlin class called robot. In this class, we will have a companion object. And inside this companion object, we will have a field called robot count. And that's going to be type integer and with initial value 0. Now, in the robot class, let's have a private variable called ID, type of integer, and this will be equal to robot count robot count plus plus. So whatever robot count will increment, and then we'll store it in the ID. Okay. And then also let's take a type as a parameter inside the primary constructor, and the type will be int type. Okay, and then finally let's create another function inside the companion object that's called format name. And that function will take a robot instance as a parameter. But before we proceed with that functions and implementations, let's create a few robot types. Okay, now in the function we can format the name depending on the robot ID. We can create a name depending on robot ID and robot type. So first let's create some kind of a variable that will hold a specific letter assigned to a type. Now let's return a string out of this function, and let's generate some kind of a string template that will return a nicely formatted string for the robot name. Okay, and before we use this robot, let's also create some kind of a factory object that will create robots in a consistent way. So let's call it robot factory, and let's make it an object so that it's a singleton object across all the instances. And there will be a function called create, and it will take robot type. And it will simply return a new instance of a robot. And inside this robot factory, let's also create a list of all the robots that exist. So it's going to be a collection of type of robot. And by default, when we create a robot, we'll add that robot to the robot index. So let's modify our function a little bit. And now add to the list. And now let's return that robot again. Okay. Now we can reuse it, but before we use it, let's add one more functionality to the robot. We'll get the robot to return us their own name, or their formatted name. And we'll pass this instance of a robot using this keyword. Okay, now we can create a few robots and then modify some of them with Kotlin object expressions. So let's create a few headers for for our code. Okay, so let's generate a couple robots using the robot factory object that we just created. Okay, so we can create and then pass a type. So we'll use a predefined type that we created in the robot class. So let's create a pilot, and then let's create a builder robot. Now let's create a robot, but then we'll use a Kotlin object expression to override one of its functions. So we'll start with the object keyword, then robot constructor, and now the body. Right, so we forgot to make the robot class open so that we can inherit from it, and then let's open up this getName function. Okay, now we just have to pass robot type. We'll pass let's pass this type, and now let's override the getName function and return we'll return that string instead of the implementation by the robot class. Alright, now we can add this robot to the robot factory robot index. Okay, and now let's go for every robot in that index. And print out their names. Okay, and let's run this and see what the output is. Okay, so as you can see, the first robot had an ID of 0. So let's go back to the class. As you can see, the robot name uses format name companion object function uses the robot ID and then the type name to generate this. And then when we call getName on an instance of that robot, it uses that function from the companion object. So just the utility function. So for the first one, the ID was 0. Then when we initialized the second one, we incremented the count. And that's the second one had ID of 1. And then first was type of builder. Type of, well, let's check. So first one was _b. And we make a mistake. Robot type builder returns B. Fighter returns F. First one was pilot. Returned P. And then second one is a builder, should return okay, so we made a mistake. So if you guys noticed that we did the when statement on robot.id, but we should have did it on robot.type, and that should give us the correct output. And let's try running this again. So robot _0, that's the ID and type of pilot. Next one is robot _1, and that's type builder. And then the last one, because it's a hacked robot and we overrode the getName function, it returned secret for when we tried to get name on that instance. And as you can see, Kotlin objects provide you with a lot of powerful functionality that is very useful. And if you play around with it and try it on your own, you'll be very comfortable with it, and it will hopefully help you. Hi guys, and welcome back. In today's lesson, we will be talking about lambdas and higher order functions. So to understand what higher order functions are, first we have to think about object-oriented context. Object-oriented context, anything is an object. Same goes for functions. So higher order functions are functions that can be passed as parameters and stored as values or as variables and returned from functions. And they're first-class citizen, which means that they can live inside classes, inside other functions, and so on. Also, this helps with the functional programming. Functional programming is pretty much breaking down complex problems into functions or multiple chained functions that provide a solution to a problem. For example, here we have two functions. One takes an input, then outputs some data, then next function takes the data as an input, processes it, and returns some output. So this input into this function, this input, can be a different function. It could be another function. So before we get into the syntax, let's understand why passing functions is useful sometimes. It can be useful because sometimes the function that gets passed has some kind of implementation or logic that you don't really care about, and then you just want to execute it. And that's probably a simple idea of how lambdas can be useful. So we can have function references. So here we declare a function, just basic function that returns a string. Then here we can store that function into a variable. And we do that using the double column keyword or double column sign. Then we can invoke that function by calling it and passing a parameter, just like the signature of it requires. And then we can print out the result. Next. So here we have a declaration of a class that has a function in it. And then if we want to use that reference to the function inside the instance of a class, first we create an instance. Then we use the same double colon operator and pass the function name next. And we store this into a variable. And then finally, we can invoke that variable pointing to that function by passing a parameter that the function requires. And I'm going to print out, we get the correct result. Okay, so here we're getting into a little bit more technical details. So how can we pass a function as a parameter? Well, to pass a function as a parameter, we have to specify the signature of the function that we're going to be passing so that we can know what to pass into this function reference and what that function, once called, returns. So that's why the signature is important. And here's the syntax. So when it's a parameter, first, as always, we have to give it the parameter name. Next comes the signature. First come the function parameters that this reference will take. So the parameters can be 0 or more, just like any function, right? Can be 0 or more parameters. And then finally, we have a arrow, dash, and then greater than sign, pointing to the return type. And then the final type is a return type, right? So parameters, return type. If there's no return type, we use unit. So let's see how to use this. Here we have some function declared, like in the previous example. Then we have another function that takes a function that takes a string as a parameter and returns a string, which is the same signature as this function here. Then what it does, stores it into a variable, and it calls that function and stores the result into the variable. And then here's the second way of calling that function. You can either call it like so, by function reference name and then passing parameters, or you can do .invoke. It's just the Kotlin's syntactic sugar. Then here's the usage. This is how we do it. First, we create a reference to our function by doing some function, that's the function name, storing into reference, then we pass that reference to a function into this function here, right? So we invoke this function and pass the function as a parameter. Okay, lambdas. Lambda's syntax can be a little bit intimidating at first, but once you get the hang of it, it becomes very easy and intuitive to use. So, first, we'll have var or val, just like a normal variable, then a variable name. Then, if this is a fully qualified field, what we want to do next is, remember, next is the type and then the assignment. So the type is the type of the function signature again. In this example, two ints are the parameter, and then this function would return an int as a return type. Okay, and assignment. Now here's how we assign the actual lambda to this variable of this type. So lambda goes within the curly braces. Then you have your parameter names, right? X and Y. These will be both integer types, like this type declares. And then this is your return statement. So this body can contain one or more statements, and the last line of this body is the returning value. So you don't have to explicitly write return. Kotlin will automatically return the last value in this function. So next is lambdas exist as an expression. Again, they can be passed as parameters, just like we saw with function references before, and stored as values. They can be declared inside functions, inside classes as properties, right? Just like any other properties. So let's look at some lambda examples. First one, we have a lambda with no arguments and just prints to the console. So we store this lambda declaration into a variable called none, and then we invoke that lambda, right? We execute it. When we execute it, we pass no parameters and it prints hello. Next, we have two arguments, 1 and 2, and both of them are type of integers. So here we shortened the definition of this lambda a little bit from the previous screen. So we're doing it variable name, semicolon, integer. Variable name, semicolon, integer. This is the types that this lambda takes. Then this is the lambda body. This is what's going to execute. And then finally, when we invoke this lambda, we pass 3 and 5 and store a result into a variable. Then we print the variable and prints the result of this function. So calling lambdas is just like calling functions. Now, multiple statements in the body. In case your lambdas have a lot of code to execute, what you can do is you can have multiple lines in your lambda body. So this lambda has one input, type of string, then the body. We do dash greater than, like a little arrow sign, and then this is the body. of the lambda. We have a count, we count the length of the input string, then we return the length is, and this variable will be inserted here into the string template. Then remember, last line of lambda is the return statement by default. So here we pass Oli, and then we print out the output from this lambda. And the output prints length is 5. So this lambda returned a string, and then we were able to print out the result. Okay, so what if a lambda takes a lambda? This is rare, but let's examine this case. So we have to declare our types. Remember, at the beginning of the lambda, we have to declare our types before the body. So we have here 1 integer type, 2 integer type, and then the operation lambda. So operation lambda's signature, it will be 2 parameters, integer, integer, and it's going to return an integer. Right, now the body of our lambda will just execute this operation lambda that's been passed as a parameter. Then we'll just pass 1 and 2, these parameters we got in our lambda, and return that. So let's see what this looks like. So what if we want to multiply 3 and 4? So we'll invoke our operator. So we call the reference to our lambda as operator. Then we pass 3, 4, right? So argument 1, argument 2, and then we pass an inline lambda. We didn't even have to store it into a variable, because you can just write it inline, just like any expression. And then, right, we had to make sure the signature matches, so this lambda takes A and B, and then what we do, we actually multiply the parameters that are passed, A and B. So this is a very complicated way of multiplying 3 and 4 to get 12. And so here's another example that's a little bit cleaner. And this is important to remember the syntax, because it's used a lot in Kotlin. Whenever lambda is the last parameter, it can actually be written like so. So all the normal parameters go first, then you close the brackets, and the last parameter, the lambda, is after the brackets. It is a little bit not intuitive and a little bit confusing, but this actually allows some really powerful functionality in Kotlin that we'll see in a couple lessons in the hands-on section when we're going to be doing complex apps. Okay, extension function and properties. Well, you can modify classes without extending them. That's why extending functions are very useful as a language feature. This is different than lambdas, so keep that in mind. And you can add utility functionality to a class directly instead of creating a utility class, which is a common pattern in Java. And you can add functions or properties as an extension to an existing class. So let's see what this looks like. You'll be able to understand why this is useful in just a second. So let's say we wanna add a function that's called print to a string class. Well, we could subclass it, but that would be a little bit excessive, right? So there's a simpler way. Or, right, we can also have a utility function somewhere that's just a static function. You can call print, and it takes one parameter that's a string, and that will just print it out. But there's another way that allows for really cool functionality. So here, we'll create a print function that takes nothing, and this will extend, or this function will be added to the string class. And then it will just print itself. This in this situation is the string class. Next, we'll do the same function, but it takes one parameter, and that parameter is a lambda, which we'll use as a formatter of the actual string. So it will take string as input and give us an output, a simple formatter lambda. And here we'll print out invoking formatter's returned value and passing this, meaning this instance of a string. And then let's give an example of a field extension. So here we'll have a string dot average character. So whenever you call average character an instance of a string, you'll get an average character that appears in the string. So how do we use this? Well, it's really simple. Here we have an instance of a string, like this text saying hello. Then when we do dot print, it prints it out to the console. So that was useful. That saved us a little bit of time. Now, what if we want to format it? How would we use our format function? Okay, so we do instance of string dot print, and then last parameter is a lambda. But remember, if the lambda is the last parameter to a function, you don't have to put brackets around it, right? It will go right after. So it's a little cleaner. And here, this statement will print out your name is Oli, because once this lambda is executed, it takes the current instance of the string, which is this, and it prints that out. And finally, let's do average character. So when we do average character, we'll just have our string and then call it our extension property, just like any normal property with the dot character, right? And that prints B, because ABC, average character, is B. Okay, and that was it for lambdas. Now let's do a few examples and get comfortable with using lambdas. Okay, so let's start by creating a new package. Let's call this package lambdas. Let's create a new file. Let's call it lambdas example. And now let's create a main function. And to start with, let's create a simple lambda that takes a name and then prints out some kind of greeting. So, do you guys remember the syntax? So, first, let's create a variable. Now let's store a lambda. And first, let's declare the lambda's type, also known as its signature. So its signature will be, we'll take a string and it will return a unit, so nothing. And, well, that's the type. And now let's actually declare it. So to declare it, we'll have to implement the type. Now first parameter is name, then there's the lambda body where the code goes. So here we will just print it and we will concatenate the strings. Right, so we declare the lambda this way, right? Type, and the type consists of the input parameter and then the return value, and then assignment. But we can actually simplify this. So because Kotlin compiler is smart, it can infer the type. So we can do this, but the only thing we have to do is specify the type here of the first parameter, well, the parameters. And now we can invoke this lambda. Just like calling a function, right? By name, then pass parameter, and now let's see. right? And that's how it works, right? It's pretty simple. Just the syntax might be a bit difficult to remember at first, and that's perfectly fine to Google the syntax if you forget it once in a while. Okay, now let's create a list of bank accounts, and then we'll use lambdas as filters to kind of chain these together and modify our collection. Okay, now let's create 10 accounts with random data in no particular order. Okay, so let's see what happens if we print this out. Oh, actually, so you can see we're actually using a lambda here. For each, if you check out the implementation, it takes an action, that's the name of the lambda, which takes one parameter and returns uint, so returns nothing. And one parameter is the 0 to 10 in this range. So to iterate our accounts collection with the lambda, we have to do dot for each, and then takes again an item. So if the lambda returns one item by default, we can refer to it, so we can do print, so print line, and then we can do it. This refers to each item. So this refers to each item in the accounts collection, but the parameter is called it always if we don't explicitly specify the name for it. So we can actually explicitly specify the name, like so, and then use that name. So here we use it, here we use give the name explicitly. So let's see what this prints out. Okay, so that printed out a bunch of bank accounts with names and balances. Now, these balances are all over the place. How do we sort them? Okay, now to filter, well, what we can do is we can actually do this. Accounts.filter, and we can specify our filtering lambda, right? What kind of a rule we want to apply. So we want to do balance is only bigger than 500,000. So to make the compiler happy, let's change this into a different type. Like that. And now let's print out all the balances. Balances for each, balance, and then we'll print out the balance, okay? So we didn't have, oh, okay, that's 5 million. What we wanted to do is 500,000. All right, let's run that. I guess we don't need that. Okay, so it prints out all the accounts bigger than 500,000. Great. What else can we do with this? So we can actually create a function with the same signature and use that instead of a lambda. So for example, instead of calling the filter like this, we can just create a function with the same signature, which is takes a type t and then returns a boolean. So how would we do that? So first we'd switch to those brackets, then we'd create a function like stats and has to return a boolean. And then because we know the balance, we can just do account, bank account, type, and then return account greater than 500,000. Alright, account.balance. Alright, and now we can actually pass reference to that function instead of a lambda, and this will be called. Yep, so as you can see, our random balances were filtered again. And as you can see, handling lambdas is as simple as handling function calls. The only difference is the syntax when you define a lambda. But if you get the handle of the syntax, it becomes very handy and very useful, as you can see with all these filtering and all. Hi guys, Alexei from codeprinciples.com here. And in today's lesson, in Fundamentals of Programming with Kotlin course, we will be looking at threading and concurrency, but specifically coroutines and how they're used in Kotlin. So sometimes you want to perform multiple functions at the same time, and parallel programming becomes very handy. Kotlin is a very easy programming language when it comes to threading and parallel operations. So large problems can be broken down into smaller pieces and solved in parallel. A lot of problems can actually be solved in parallel. And often when you have user interface and some kind of a background thread, that's a good way to do work because your user interface is on the one thread and then your background tasks are on separate, and your user interface stays smooth and fast. So you have to be careful about race conditions. So race condition is when you're trying to read, or actually trying to write from multiple threads to a single object. So because they're trying to write to it at the same time, you get weird behavior sometimes and you end up with weird states. So atomic objects and synchronization blocks help to overcome race conditions. So the reason why we'll be focusing on coroutines and not threads is because coroutines are more powerful, they're more lightweight, they are stackless, meaning they take less space in the memory. But that there comes a little trade-off there. You can do as much as you can with threads, but it's still a very powerful concept. Then threads, whenever you're doing a blocking operation, that whole thread will be blocked, but that is not the case. So you can have multiple coroutines running on a single thread, and any number of those coroutines can be blocking, but the whole thread will not halt, will not wait for that specific coroutine, hence the name coroutines. So they're able to run in parallel without blocking the main thread that they're running on. So that happens, or that's allowed, because the coroutine is actually ran in pieces alongside with other coroutines. So in this example on the right side, we have subprogram A that executes, stops, then subprogram B, which is another coroutine, will start, then we'll get to a point, then the first one will continue while the subprogram B stops, then once it executed for a bit more, goes back here, subprogram B finishes, then we go back to the first one and finish that. As you can see, they're executed in pieces, but they are parallel at the same time. So that's how coroutines work, and they actually are just as fast, if not faster, than threads. Because threads are so resource heavy, you can't really spin out a million threads. That will take a very long time to execute on an average computer, but running a million coroutines at the same time, however, is not that resource intense, and you can actually probably execute them really fast. Now, Kotlin is really good language syntax-wise for synchronous programming. And coroutines are continuation passing style programming, which is very common in things like video game development. Unity uses a lot of coroutines. And coroutines are becoming more and more popular lately over threading simply because they are a little easier for developers to use and a little bit harder for the developers to mess up. Now, let's see some syntax. So, once we import the coroutines Kotlin library, we can have a couple of lambdas as that we can call. So first one is run blocking. Run blocking, the body of this lambda will contain our code, our asynchronous code, simply because we want to run it in a blocking way until it's done, just so that our main loop doesn't finish until the asynchronous tasks are done. So in the first one, we will use launch, a lambda, and we will fake some long-running task by delaying that, then printing 2 seconds later, so this is in milliseconds. 2 seconds later, we print out a string. Then, once this job is done, we will finish the main. So, we declare our work inside this launch task, and because the result is not important, we'll use the launch lambda or launch block. That returns a job, and then we kick it off and we join. So join function on this job object that this lambda returns means that we will simply wait. So if you have multiple jobs, you can join all of them together. We'll go into that in a second. Here we have another example. We have async a lambda. So async is different from the launch because async returns a value. Well, in this case, it doesn't really, but usually async is used to return a value from asynchronous task. So in here, when you're using async lambda, you get a deferred type of object back, and then for it to finish, you have to call .await instead of join. So this async, the body of this async lambda executes asynchronously to the main thread that's running, and then we wait for the execution to finish 2 seconds later. Okay, so how do we combine multiple asynchronous responses into one? Well, it's actually difficult with threads, but with coroutines, it's very simple. We have 2 asynchronous blocks that have some kind of asynchronous operation inside them. Then, when we wanna join them, we will call .await. So these two can be running for a while, but once we reach this line, we will wait for both of them to finish, and only then we can print this out. And this is a very nice way of syncing, very simple way of syncing multiple things together, multiple parallel things. This is really easy syntax. Right, and it's almost like you don't have anything happening in parallel, but you actually do. These two run on a different thread than the main thread. Or they run in parallel to the main. So next, oh yeah, and this is how those functions, these long-running tasks are implemented. They just delay 2 seconds and they return a string. So in this example, both functions fake some difficult work by delaying their return value by 2 seconds and then return a string. But this print line only takes 2 seconds because both of them run at the same time. Then in 2 seconds we print out hello, world here. Well, it might sound very confusing at first, but let's try and write some code with lambdas and some asynchronous programming, and you'll see that it can be very simple and easy to write asynchronous code in Kotlin. So to begin, we'll actually have to import a coroutines library. We will right-click on our main module, then we'll scroll down and we'll select Open Module Settings. Then we'll go to Library section and hit plus button, and then select from Maven, and here we will type in org.jetbrains.kotlin semicolon kotlinx dash coroutines dash core semicolon 0.21, and that's gonna pull down this library and set it up as one of the dependencies for our module. Okay, let's hit OK and OK again, and you can see it appeared here in this panel. And it might look different for you, the other dependencies that you have in the project. So you should probably have Kotlin and just the coroutines one. Okay, let's press OK. And now let's create a new package. And let's create a new file. With the main function as always, and to execute any kind of parallel running code, in our case any kind of coroutine, we will have to block so that the main doesn't finish before the actual parallel functions finish. So to do that, we will wrap our code in a run blocking. There we go. And if you imported the coroutines library correctly, you should, when selecting run blocking, you should see an import Kotlin X coroutines experimental run blocking. Right, that's the import for the library, and that's the blocking lambda that we're gonna be putting our code in. So for this example, we will actually create 1 million people, and then we will calculate the average age asynchronously of 1 million people and print it out to the output, to the console. First, let's create an object or a class called human, and let's hold a name and age. Okay, now we will create a loop that creates 1,000,000 people, and then asynchronously we will try and add up all the ages. So check it out. This is how we do it. Okay, so what we're doing here is we are creating uh, a range from 0 to 1,000,000, and then for each item we are mapping that to a human person asynchronously, and then we're trying to sum up by the age value once all of them have been initialized. And now let's print out the average. Okay, so this is how we calculate the average, our total divided by 1,000,000, and let's see how long this takes. This is probably going to take maybe 5 seconds once we run it, maybe 6. So let's see. Okay, there we go. So average age is 45, and that's about right because we're randomly picking a number between 0 and 9. And the calculation took about 8 seconds, which is pretty good for 1,000,000 people. So let's do this again, but let's put a delay of, to prove that it's really asynchronous, let's put a delay of 2 seconds. So if the delay is 2 seconds and it is serial, like one after another, then if we delay 2 seconds every person in 1,000,000, that's going to take a long time. But because it's asynchronous, let's see how long it takes. So if it took us 8 seconds before, how long would you guys think this will take us now? So that took about 10 seconds, and that's a little bit, 2 seconds longer than before, which accounts for this delay. So one more useful thing that you guys can do is you can actually move this logic into a different function. Okay, so for our blocking function, or in the coroutine sense, actually it's not blocking any thread, our suspending function, right? We have to annotate our function with suspend keyword. So what happens is actually this function will return a deferred object. So if we hover over this, this will say human, but the reason why we have to do .wait is because this is actually a deferred object. That's a wrapper for the human. So we await on the deferred object, as you can see here, and then we grab the age from it. And the age is this, right? Human.age, and it's inside the deferred object that we await once the suspending function finishes. So the reason why coroutines are so powerful is because the computer can kick off multiple suspending functions at the same time and then take turns executing each one. And then all those deferred objects, they're being awaited on, and then the age is summed up here. So let's see, it should be the same output. Okay, that calculated the average age, and that did it in about 10 seconds, same as before, right? But it might be useful for you to move your logic into specific functions that you can annotate with this keyword and then kick them off in parallel, side by side, like we did here. So let's do one more cool thing. Let's create a timer that counts while we are doing that long-running operation. So how would we do that? So we can actually create another function called a start timer. And let's start this timer at the beginning here. Alright, so this should count 1 second forever and then print it out to a console. Well, forever until we are actually done awaiting on this, the sum. Okay, so we had an issue. We did not, we kept printing out, we never stopped, right? Can you see that? So to fix this, we will actually return a atomic boolean. So what this is, it's a thread safe boolean that we can toggle from the outside and stop our timer. Now we will grab it here. And then once we're done, we will stop the timer boolean. We forget the async wrapper. So we are getting stuck in this while loop. So to get around it, we'll use launch lambda, and we'll move our loop inside this lambda. So the launch lambda difference is that it really doesn't return a deferred object wrapper, it returns a job. And we don't really care about this job's completion because it's gonna stop once the flag is set. So let's see. There we go, so that took about 9 seconds and it calculated the average age and printed it out and then exited the main loop. So let's quickly walk through what happened. So because we had some async functions, we had to run a rapid and a run blocking lambda, and inside the body we can have a mix of non-blocking and blocking operations. So, first we kicked off the timer. Our timer function increments a counter in an asynchronous manner, but while it starts doing that, it also returns a kind of like a flag that will toggle. We toggle outside to stop this infinite loop. And that starts the timer, and that's going in parallel to our execution. Then our execution creates a million people. It takes 2 seconds to initialize them, and then creates an array of million people, and that returns deferred object wrappers. They're like promises of some kind of a future action that will happen, and we await on that promise, on that deferred future action, and then we grab the age once that's complete, when that's heavy work is done, which is 2 seconds in this case, but in real world it can be longer depending if you're doing a network call, if you're doing a database read. And then we do a final operation that will calculate the average of 1,000,000 people, and that's executed in about 9 seconds, which is pretty good since we're doing all this in parallel. And doing this with threads would take way longer than 8 seconds. And that's about it for asynchronous stuff for... Hi guys, and welcome back to the course. In today's lesson, we will be talking about clean code and what it means to write clean code and some of the general ideas and approaches of how to create a easy to maintain and clean code base. So the first thing I want to talk about is coupling. So it's a degree of dependency between two modules, and the less dependency there is between them, the better. Meaning that if you change or update one, the second related code module should not be affected in any way. So you can use interfaces to provide general rules for interactions between modules that have to communicate. And also you can let a third-party object provide dependencies. For example, if you have two modules communicating, you can provide the configuration of both of them via injection. So another module can configure the other two so that both don't have to have any kind of configuration dependencies and configure the related modules. Next, cohesion. So a strongly related set of functions is always good. You want to group related logic and related problem solving in a single module. And this allows you to hide certain information. So only specific private fields and private classes can be shared inside the module and solve problems internally, whereas you don't have to expose that kind of functionality with outside modules. This allows you for more encapsulation, more object-oriented code, whereas their behaviors are not influenced from the outside. Their behaviors are fully controlled from the inside of the module or a class. Okay, maintainability. This is a big one. So whenever you're working as a developer, you want to write your code in such a way that there's the new developer who starts on the same project as you has an easy time understanding and learning the code. You don't want to make it overcomplicated so that the next developer struggles to understand. You also want to comment a lot of your code so that people can read the comments and know what's happening and know the purpose of the functions. So another part of maintainability is you want to be able to change the internal implementation of a single module without having to change anything else in the outside system. And coding in such a way lets you implement tasks and functions and functionality way faster. If you code in a way where you only have to update the internal logic of a single object or module, you don't have to touch and rewrite other parts of your app. So it's always important to keep that in mind. Next, extensibility. This one is a little bit trickier to implement than the other few. So basically, you want to write your code in such a way that it's easy to subclass, it's easy to extend, and then the subclasses have are able to change the behavior of the parent class. So this takes a lot of planning and just thinking how to define your base classes in a way that they're easy to subclass, right? Because often ways you have to decide where's composing your objects from other objects is better than inheriting from a parent. And if it is approach you take, you have to decide how to define the parent class in a clean and structured way. And also, new modules or new classes should not be concerned with breaking other modules. You want to be able to have strong enough rules that when you create a new module, it follows the rules of the whole system or whatever the purpose of that module is. And also, modules should only be concerned with their own internal states, internal logic. They should not be controlling or modifying states of other modules outside of them. Reusability. Now, we don't want to rewrite the same code. If you can write it once, do it. And that way you can reuse that single code. And you want to be able to reuse functions, utility functions, constants, classes, views if you're making UI, layouts, combinations of views, and also modules should not be dependent on the rest of the system. This way you can reuse them in a new system as well. If you have a useful utility class or a layout that looks really good, you can always reuse it in a different project. And functionality of a module should be well defined and complete. This way you decide strict rules for a module or a set of modules, and those rules make it more reusable. You can swap different implementations of a module and still be okay. So understanding the tools you're working with and design patterns is crucial for a developer. You have to know the tools you're using. You have to know the IDE that you're using. You need to know any command lines that you may or may not be using, right? You have to know version control. You have to know design patterns, because all of this helps you be a stronger and a better developer. And knowing ins and outs of the language can reduce coupling and increase cohesion. If you know how to create clean classes and objects, you will make it easier for other developers and for yourself in the future to maintain the code. And you have to be strict with your rules, right? Like design patterns help you make your system modular and enforce a set of rules that all the developers will adhere to. There are software design patterns for things like we've already covered, like singletons. And there's also architecture design patterns. This is how you architect your classes together to make systems. And we will cover these things in the next lesson. But for this hands-on section, we will actually be making a tic-tac-toe game that will use that will have some user interface, some buttons. So stay tuned. Okay guys, so in this lesson, we will be creating a simple tic-tac-toe game. So let's go ahead and create a new package, call it apps. And then inside this package, let's create a sub package. Let's call it tic-tac-toe. And And inside that, let's create a new Kotlin file. let's just code main. Okay, but before we get started, we will have to import a library that will allow us to create a nice user interface. And depending what platform you're working on, and it doesn't have to be Kotlin, other platforms provide you with libraries that let you create UI, user interfaces. So what's more important than the library that you use to create UI is actually all the programming principles that you know, and that knowledge is transferable. Whereas the library is platform specific and all of them are different. But your principles and your architectural knowledge should be transferable. So let's go ahead and right click on our main module and then select Open Module Settings. Then we will go ahead, go to the library section in the left hand panel and hit plus from Maven. And in here, we will type in no.tornado semicolon tornado effects semicolon 1.7.17, and we will press OK and OK again, hit OK, and then you will see that in the bottom right corner will say that the files have been downloaded, and you'll see that the Maven is doing some processing in the back there. So now let's go ahead and create our main function. Inside this function, what we're going to do is we will call application.launch, and this is going to be a JavaFX application. So we'll need an appropriate import, and let's call our app tic-tac-toe. And here we're just passing the reference to a class that we will define in 1 second. So as you can see, tic-tac-toe is not created, so we will have to create it. And we will have to inherit from app from tornado_effects, which takes another class reference in the constructor. Let's call it main view, and let's define this class main view. So this main view class also inherits from a class called view, and let's import it, and then let's give it a name. And here the only thing we have to override is the root view, which we will define as a grid pane. So that's a grid element. And this library, tornado_effects, loves lambdas. So inside this grid pane, it takes a lambda. Inside this lambda, we will initialize all of our grid elements. So we will have a 3x3 grid. And let's do it with 2 ranges from 1 to 3. We will have a row, and then inside that row we will have items. Okay, so here we created 9 views, and we will create this tic-tac-toe cell view, right outside the main view. Again, we have to inherit a view, but this time we will inherit from item fragment. This takes a cell state as a parameter. So let's first define a cell state. So we will have an enum called cell state, and we will have 3 states. Can you guess what they are for a tic-tac-toe? Right, empty, then circle or cross, and then circle. And same as before, for the tic-tac-toe cell, we will have to override the root. And here, we will make the root as a button. Because remember, tic-tac-toe cell is 1 out of 9, and they're going to be created dynamically, initialized dynamically, and each one will be a clickable button. So to define this button, first we'll have to give it a width and a height. Next, so we'll have to create a graphic for the button. So we'll have to manually draw an X or a 0 or an empty cell. So to do that, we'll have to create a graphic that will equal to a group. And this group will contain a rectangle, a cross, which is another group, and a circle. And this circle is going to be actually different from our graphic. Right, so the graphic is a combination of a rectangle and then a group that will have the lines, and the circle is just going to be a simple circle. So let's configure them with sizes and colors. Okay, so let's run it and see what this looks like. And we see an empty grid of 9 cells, and they are clickable, but they don't do anything yet. So let's add some states, and let's add a click listeners. So first, let's save the references to the circle and to the X, and using those references, we will then toggle them. So we'll create two fields inside our tic-tac-toe cell. We'll make it the lateness, which is a modifier for a property that will allow us to set it later than when it's initialized. So the issue with variables, right, you have to set them right away if it's not nullable. But with lateness, it allows you to set it at a later time, but be careful if you try to use it before you set it, that's gonna crash your application. So make sure you always set it before you use it. Okay, so this is going to be our cross, this group. Then we will have a circle. Which will be this circle object. And see, this is a function that takes a lambda. This function is called circle. So the syntax is a little weird if you're not used to it. But if you hover over it, you can see this function, this lambda function, or this function that takes a lambda is an extension function to a circle class that then returns a circle. So it's a convenient way to configure the circle object's properties in this type of syntax. Okay, so we have references, but now let's add a mouse click listener, and then let's toggle visibility of the graphics. Yeah, so we need to have some sort of a way to keep track of a cell's state. So let's create another variable and initialize it with a empty cell state. Remember the enum we defined before. So now let's also create a global variable where we're gonna keep track of the who's the player who's taking turns. So the first person is gonna be playing as cross. Now let's take a note of this. So here we'll just switch between the empty and between cross and circle and cross, depending which ones you have. And then if it's empty, it will be always empty. Okay, let's run it and see what we have. Okay, so the first person who starts should be as an X, and we have some sort of an issue. So let's see if we miss something. Yes. So for the cell state property, let's create a setter and update the field first, and then let's toggle the actual visibility. That's what we forgot. So you have to toggle the visibility of the cross and the circle views, the graphics. So it's visible, and let's check if this value is cross, and then this the same but the opposite for the circle. Okay, let's try running this. Hopefully that fixes our problem. So we have a problem with axes not rendering, but circles are rendering just fine. So okay, let's see what the problem with the axis can be. So cross, and then the lines and visible. Okay, so the problem was we had this outside the graphic. So it was actually overlapping. And that's why we couldn't see the cross behind it. There we go. So first layers cross, then the 0, then cross again, then 0, and so on. There we go. So it's a simple tic-tac-toe game. As you can see, it took us less than 100 lines of code to create a tic-tac-toe game. And we used all the knowledge we learned in this course to create the game. And the framework that we used for the user interface is irrelevant, right? On Android, it's going to be a different framework. On web, it's going to be a different one. So what's really important is seeing how to use the fundamentals of programming across different platforms, across different frameworks. So let's quickly go over what we've done in this class. Right, so we created a simple app that had one view, and that view had a grid pane that had 3x3 grid with rows, and each row had 3 tic-tac-toe cells. So a cell was a simple view that was a button, and that button had some properties like height, width, and then a graphic. So the graphics could have been either a cross or a circle. And then depending on the state, we would toggle the state. During a mouse click, we would toggle the state and switch between a cross and a circle. And depending on that field's state, we would toggle the visibility. And as you can see, all of these programming concepts we've covered in the previous course. The only thing that was strange or new was configuration of the views. But the Lambda syntax makes it pretty intuitive, and it kind of reminds me of HTML. If you guys ever seen HTML, it also has a lot of these nested tags or elements, right? Have multiple elements inside another element and so forth to compose your views. And you can research more on Tornado FX and look up more tutorials online if you're curious about desktop development. And you can write your own applications. If you're interested in desktop development, and now you have the fundamental knowledge and you have the knowledge of the language, so you can research the different frameworks and decide which one works for you and create simple desktop applications.